It's already time, 2:30. Imagine that. Before we go into the second part of our program on this lovely day, which is in partnership with Digital Switzerland and powered by Helvetia, imagine what? The partner of the day is Helvetia. And coming up next is also something which has something to do with a certain Swiss insurer. You guess it's okay. Doesn't matter what you guess. You can keep on guessing because before we start, we set the rules, and the rules are in the Code of Conduct, which is a version of the code of the Berlin Code of Conduct. But to give you a yes. Yeah, you see, I did not drink enough coffee. I rolled the video with the Code of Conduct for you now. So, here I am back. I'm loaded with coffee right now, and believe it or not, next up is how to improve your developer happiness with GitOps. You know GitHub and other Git things, and you hate operating with Git on the command line, but GitOps, you've never heard of it? Well, I think there is a solution to this, and talking about solution, there are two solution architects from Helvetia, Lars and Basil, and I will roll the intro now, and then you can never guess what will happen. We will join them on the stage. See you in a second. Hi Lars, hi Basil, how are you?
Hey, good afternoon, Stefan.
Hi.
Thanks for having us at this year's WeAreDevelopers Live Week. We're broadcasting live from Switzerland, from St. Gallen. Actually, we're now in that beautiful building you can see on our start slide here. It's a building designed by Herzog and Dönero, really beautiful. We can't show you the view we have from here to the Lake of Constance, but anyway. And yeah, we're going to talk about how we try to make developers happier with an approach that is called GitOps. So few words about us. My name is Basil Brunner. I'm a solution architect working with Helvetia for almost 2 years. Traditionally, my background is more in the programming area. I used to do a lot of Java programming, and then got more and more into the field of DevOps, into operation kind of things. Got in touch with all this cloud native stuff, did a lot of solutions based on AWS in particular, set up some Kubernetes clusters, and did a lot of work with OpenShift. And yeah, I'm currently working in a very interesting project together with Lars. And yeah, we'll give you a little insight in what we're doing this afternoon.
Yeah, and as already hinted, my name is Lars Christensen, and I'm also working as a solution architect at Helvetia. I haven't been there for so long, just I think 5 months now, but I think I've adapted quite well to the Helvetia. I like it a lot. It's very different from what I've been doing last many years, I've been working in a lot of different startups, from everything from fintech to well, you know, embedded software development and stuff like that. But in a way, working in this team has also kind of like a startup feeling. We challenge everything. We don't. We try to be agile about things and not get stuck in the old patterns. So it's an interesting place. Yeah.
Okay, so let's get started. Yeah, we have an agenda for you. It's not what you usually see on a traditional agenda slide, not a lot of bullet points here, but our idea is that we're going to tell you a story about integration and how the solution that we're currently designing here at Helvetia is improving developer happiness. Before we actually get started with the slide, we want to encourage you that you interact with us over the Q&A tool. So please go ahead and post your questions right away into Slido if they come up. Do that during the talk. Do also have a look at existing questions that are already asked and upvote them, because at the end of our talk, we will answer those questions that got the most thumbs up, the most votes. So it's easy. If you are not already there, go to slido.com and enter the hashtag WeAreDevs. Or if you have a mobile at hand right now, you can also scan the little QR code on the right side of the slide.
So we'll give you a moment to do that.
Yeah. Was that enough? Okay, good. Well, before we get started with the technical aspect of our talk, I want to give you a little context about what we're doing here. And to understand that a little better, I think it helps if I talk a few minutes about some very important strategic business directions that we have here at Helvetia. So one of them is called ecosystems. So what is an ecosystem? The slide you can see here is about the home ecosystem that Helvetia is building. So basically, an ecosystem is something built along a customer journey. In this case, the journey, as the name implies, is everything that is related to homes. So it's about informing yourself, searching for a new home that you could buy or rent, make a decision whether that is a good opportunity or not. Then, depending on whether you go to rent or purchases, if you're going to purchase the house, you need to be able to finance it. You need to do all the paperwork. Maybe you need to do some build, construction work, and so on. Of course, at some point, you also need to insure. The same is true if you decide to rent your new home. You might need a lease agreement. And then after you moved in, there is things like at some point you might need to renovate if it's your own house, or secure it, get a new lock at the front door. And at the end, you might even want to move out again. So as you can see, along this customer journey, we as a traditional insurance, we don't have that many touch points with our customers. And that's something we want to improve by doing partnerships with a lot of other companies. So basically, we're looking for partners that can play an important role along that customer journey. And we're trying to build a bundle that provides more value in combination than something that is only done by one or the other company. So ecosystem is one of these strategic directions. And then we have the second one. It's called omni-channeling. So what does that mean? Again, we're an insurance company. Very traditionally, a lot is done in sales, direct sales. So our salespeople go out to our customers, shake hands. They send them letters, traditional letters, of course. where they do phone calls, these kind of things. Yes, we have the modern tools like emails and the website. So yeah, but over the last 10 years, the channels quite exploded in that space. So nowadays you have countless of chat applications like WhatsApp or Instagram, Telegram, and so on. You have a bunch of mobile applications running on your device. We have, as we do right now, video conferencing. We have maybe even smart home devices that we tell what we want to do next and so on. And the idea of omni-channeling is that our customers can always select the channel that makes most sense to them if they want to interact with us. So they should not be tied to one channel. If they decide they want to now swap from, let's say, traditional phone over to SMS or from social media back to email, that should always be possible, and they should get meaningful responses from our side. So that's the second direction that we get from our business. And interestingly, about 2 years ago, I don't think it's 2 years, maybe 1.5, an official cloud strategy was implemented here at Helvetia. And one important imperative in that cloud strategy is this sentence here: integration capabilities are a key driver to leverage omnichannel analytics and ecosystem functionality. So as you can see, the two very important directions that the business wants to have found their place in the cloud strategy in a very prominent sentence. And for us in the project that we're currently working on, the cloud strategy is not just a piece of paper, it's really something that enables us to build modern solutions. So our cloud strategy is a multi-cloud strategy. It's even a hybrid cloud strategy. So we still have an on-prem data center, but we move more and more workloads to public clouds. At the moment, that's mostly AWS, but we're also ramping up Azure. Over the last 2 years, we built a container platform based on OpenShift. We're currently in the move of bringing a lot of traditional Java applications over to that container platform. And so these tools, they allow us to really use cloud native design philosophies for building our new solution. Yeah, by the way, exactly this Hafenheinz, as we call him, is the mascot of the Helvetia container platform. That's why we are wearing the t-shirt today. In the end, why is it really an enabler? It just allows us to iterate way faster than before. And by iterating faster, we get also that feedback from our stakeholders earlier than it was the case before. So that whole cycle of ideation, development, deployment, going into production, that is just reduced. So yeah, really important for us. So I mentioned integration quite a few times already. So integration, for those who don't know the term yet, is just connecting applications one and each other. And I think the most dominant technical way to do that is over REST APIs. REST APIs are eating the world. That is something you can read and hear in other talks. And I think this diagram here explains it really well. REST APIs do power the modern web applications, like the single-page applications. The same APIs are then used for your mobile applications. You're going to connect cloud-based software as a service applications. You do that with your partners. You even introduce REST APIs to your legacy applications, and yeah, all done over REST APIs. So as we have those two strategic directions, as you can see, REST APIs are really important to us. But what do we actually need to do if we want to expose such an API? In the beginning, the picture looks like this. On the right side, we have our application or the service that is actually offering that API. And on the left side, we have our customers, our partners that are connected over the internet, and now they want to access that REST API. So as a first step, we need to establish connectivity to the public internet. Sounds easy, but in a big environment as we are, that's not always the most straightforward process. You need to find someone that is assigning you a public IP address. You need to have the DNS entries made. You need to think about protecting your infrastructure from DDoS attacks and these kind of things. Then, as a second component, we want to protect our APIs, right? We want to do some payload validation and filtering. We do injection prevention, like SQL injection and those other injection attacks. In some cases, we might want to do some virus checking on the payload. So we just want to make sure that we are meeting a base layer of security. Then we need something that is called an API gateway. So an API gateway is basically a reverse proxy that is doing the internal routing to our upstream services. That allows us to place the services here in the Helvetia network where we think it makes most sense, and we can just reroute the things in the API gateway. But it does a few more things like user management and authentication, and we also do rate and size limiting on that API gateway. Last but not least, on that picture, we have an identity provider. And between the API gateway and the identity provider, there needs to be a connection because the API gateway needs to provision API clients on that identity provider. And on the API gateway, we need to validate incoming access tokens, whether they are valid or not. And yeah, if we can pass on that request or if we should block it. Yeah, these are the technical challenges, and beside the technical challenges, we have a bunch of organizational challenges that we're facing when trying to expose such a REST API. We have some architectural guidelines that we need to meet as we are a finance company. We have quite a few regulations that are made. We have internal security policies. We have governance rules. And all of that needs to be taken into account if we're trying to expose an API. Well, how do we do it today? It's basically a lot of manual coordination work. So in the middle here, we see our developer, and he or she needs to coordinate with many stakeholders during development phase. It's mostly about architecture, getting feedback about the design of the application, or in particular the REST API. Then in the process, there's info security that wants to have a look at your application. You need to talk to the network department to get that connectivity that I mentioned before. Our web application firewall team is involved when it's about the protection layer. And yeah, it's all manual handovers. And as you might can think, this is or introduces a lot of friction, right? Because it's not always the case that if a developer walks over to the network department that they have immediately time to fulfill your request. You might stuck there in a wait loop, and yeah, that is just taking usually weeks, if not months, until we get an API deployed. But in the end, the conference is called WeAreDevelopers, and yes, exactly, that's what we are. And in the end, what we want is to deliver features, right? We want to solve that problem that is in front of us. We want to find good solutions on the technical level, and then we just want to ship. And we don't want to be stopped by all these technical as well as organizational challenges. But there is another important aspect to it. It's time to market. So as you can think, nowadays it's just no longer acceptable to use a couple of weeks or even months to implement a new REST API. Because if we think back about that thing about ecosystem I mentioned earlier, there might come up an opportunity with that unique startup that we want to take, right? And we want to integrate with them as soon as possible, because if we're not doing it within the next couple of weeks, a competitor of us is taking up the opportunity, and we're left where we are. So I think that should be enough as a context. And now we meet the Helvetia integration platform, and I hand over to Lars, who is going to give you a deep insight. So please, Lars.
Thank you, Basil. So now there's a lot of, with this context, a lot of, let's say, pain points and friction to solve. That's a tall order, but let's see what we can, or what we did about it. So first, I would like to just take a brief moment to look a little bit closer at the API gateway, since that's this it's a central component when you want to expose an API. So as Basil already mentioned, it has a role in protecting the resources, rate limiting, and also doing the gatekeeping, doing authentication, and also what we call aggregate different backends or services into a unified interface where you can move the parts around in the back without this leaking through to the users of the API. But then you can also do things which you might not have available on the backends, right? So, for instance, you might not have an authentication solution on the backend. You might not have metrics or analytics on the APIs, and this is also something that you can then do on the API gateway, which takes away the responsibility or the work, the complexity from those applications. They don't have to bother with that. So they get a lot of stuff for free, and then they can add what they then need besides that. So that's some of the touch points or the concerns that an API gateway handles. But then there is this bullet point called custom behavior. And that's an important one because we want the solution or an API gateway to be open-ended because we do not know what tomorrow will bring. And tomorrow we might have new requirements. It could even be security guidelines. It could be GDPR. We have to do some specific logging in a specific way, and the API gateway can't do that today. But then we have as a requirement to the API gateway that we use that we can then extend it and then support these new requirements. And then the API gateway, exposing APIs, that's not something that stands alone. That's also part of a larger concept or topic called API management, where you want to be able to find the exposed services. So there is you need to have discoverability. Which kind of service do we already have exposed? Then I can find something that I don't have to build it on my own, or I don't have to, as you might do otherwise, know someone who knows how can I connect with this thing. This should be all automated and easily accessible. Then you also want accountability. You want to know this API, who owns it, who exposed it, who can I talk to if there's a problem with it. If I want to extend it in some way, if there's some more information that I need, then I need to know again who to talk to. How can is this something that we can solve? And that also ties in with the lifecycle management. APIs are not forever. Sometimes you will retire an application and the API, and then you would want to be able to get in touch with the users and also be able to tell them this API will disappear in, say, a year. So you have a year to transition to this new solution. and then everything can be made or handled properly and in good order. So there's a lot of concerns to these topics, and focusing a little bit about the on the API gateway architecture here at Helvetia, how we want to do this. You might have seen earlier on the slide from Basil that there was this Freescale logo. That's the API gateway that we use, and it has the property that there is a control plane and a data plane. They're separate from each other. And we want this because this gives us the, this is a more resilient setup where you might imagine that the control plane disappears due to some kind of a network issue. But in that case, we still want the API gateways themselves to be able to continue handling the data traffic that is and route it to the exposed services. And not all API gateways can do this, but the one we chose can. So that's important. So we have this resilience factor. The other part is that we want the data plane as close as possible to the actual backend services. If you think about it, this is just another abstraction. It's an interaction between the backend systems and the other systems, and that has a cost because traffic goes in, gets processed, gets forwarded, and if you then minimize the distance, if you will, between the backend services and the API gateway, then you also minimize latency and you optimize basically the performance. So that was also important for us that we can deploy specific API gateway instances close to the backend services, be that on-prem in our own data center or on OpenShift on Amazon or on Azure or wherever it should be. But we can provision everything through our control plane in a central way. So now, GitOps, what, right? We haven't been talking about GitOps at all until now. We've just been setting the stage a little bit. So here it is, right? Most of you might know it already, and then it's kind of maybe obvious, because it is kind of the obvious thing that we're doing here. When we want to expose an API, we store the information needed to do that in a Git repository. This Git repository is the single source of truth. From this Git repository, we can extrapolate the entire provision system. So if the system disappears, someone pulls a plug on OpenShift or Amazon and they restart and they forgot everything, then we can just, we just run it again, our GitOps solution, and then everything is back up. So the way to work with exposing APIs is then also through the obvious way, that is to create a pull request with the desired changes, and then those changes can then be reviewed and then merged, and then everything will be provisioned. And at Helvetia, we use Bitbucket for this, and I'll show you later a little bit. You'll see some screenshots which are Bitbucket specific, but you can do this kind of thing with any, I suppose, any kind of Git service, like GitHub or Gitea or something like that. But we use some specific features. We have the pull request reviewer flow. We use merge checks, so we can look at the pull requests and check, do they make sense at all? We can then provide feedback using something called Code Insights, which is a reporting facility of Bitbucket. We also have other outlets for the developers like Slack and email and so on and so forth. And then we also use merge strategies, which means that we can do automated merges based on certain criteria. So that's kind of setting the stage for GitOps. And showing the process in a way, it looks like this. We have the pull request being created by a user on the left-hand side in the repository. This triggers an event to, we call it a self-service application, because the users can service themselves by using the pull request flow. Then we validate this change. As I mentioned, does it make sense? And if it's okay, it's clear for being merged. And then when it's merged, then we can reconcile the new state of the Git repository onto all of our components that needs to be provisioned. And we see them there on the right. We have the API gateway, we have OpenShift resources, we have the web application firewall, the WAF, we have the identity provider, and that's of course quite a lot. And if we count it up, how many resources do we actually have to touch to update or create to expose an API? Then we end up with the number 22. So that's quite a lot of things that you need to touch to do that. And that's of course an unreasonable burden on the users. So our job here is to, from a technical standpoint, is to simplify this in a way that makes this manageable and also pleasant. So we do this by, on the technical side, by using standards like OpenAPI version 3. So you specify your APIs, your REST APIs with OS 3, which is also something that you can auto-generate tools for that. We use OIDC, OAuth 2 flows, and then also we have the defaults, and the defaults is almost or is exactly as important. That has to do with all these other workflows that you have the handovers with the different departments. That what we expose is something that is then a priori approved by those departments, right? So we have to make sure that we provide this uniform interface where the developers don't have to concern themselves with that. So here's an example of the producer side. We see here, this is inspired from the Kubernetes YAML definitions. There is a kind, so it's basically what kind of an object are we dealing with here. This is an API definition. We version it so we can later publish new versions of it and deprecate older versions. We see that this API definition is an Open API spec version 3. There is a domain there, so this is where we want to expose our API on that domain. We have the API name, we have the service name. There's a little bit, unfortunately, named Hello API here. It could be Hello Service. We have an owner of the API definition. We have a deputy owner in case the owner is not around. And that is again this stakeholder management accountability that I talked about a little bit earlier. And then finally, we have the API specs, which is now here defined only for the development stage. There are also other stages like integration or production. And if we take a look inside this spec, that's just this Swagger or OS 3 Open API version 3 specification file. And this is a very simple example where you have a path which allows a get, where if you get that path, the response should be 200, okay, and then probably a string, which you might imagine would be world. So it's very simple, and as I said, most tools or frameworks that you use, they can just generate this from your application, so you don't have to write this yourself. And since that was just the producer side, then of course there is also the consumer side, and that's what we add here with the subscribers, so we can have many subscribers to a single API definition. And also on the subscriber side, you have to say, who are you that are subscribing? There's an owner, and again, a deputy owner in case the owner is not around. And then there is a name, which is the link to the IDP that we saw earlier, so that we can provision the IDP with information such that the users can obtain a role for this subscription, so that in the end they can get an OIDC token that will get accepted by the API gateway. And this all ties together to, well, basically comes together like here below, where you see how you could actually then call the API exposed by this definition. That's probably not very interesting for people outside Helvetia, but there you have it. So doing this, of course, means, or this gives us the opportunity that we have this structured way of specifying APIs that we can automatically validate them. And this ties also into these processes, the manual handover that you would otherwise have to do, go and check with other teams, does this look okay? We can do this manually. So we can check, or manually, sorry, automatically. So we can do correctness checks, does this specification look okay? Does that have the required fields? Are there conflicts between the different API definitions? And we can do semantic checks. So again, stakeholder management, we can involve the users, the producers, if needed. So if someone, a third party, comes in and wants to propose a change to the specification, maybe adding a new path, then we can automatically get hold of the stakeholders, and they can then come in and approve it, or and also the users in that case. Or if it's only, let's say, we remove a subscription, then we only need to involve those owners of that subscription and not everyone else. So we can minimize the stakeholders that need to be bothered to go and take a look at it. We can do semantic checks on the usernames that do these actually exist. We can do stage differentiation. Before we saw an example of the development stage, but we also have the prod stage, and we would like to, of course, on the prod stage, to do all checks, make everything very strict, make sure that everything is okay. But on the dev stage, we can be more lax because this is not going to be exposed to real, and then we can remove some of the stakeholders from the equation so that the developers can iterate quickly while developing, and then when they go to production, they will then have to get the actual buy-in from the stakeholders, from the owner of the API definition. Of course, they can then just agree with them upfront, show them the dev version, and then it should be really just a matter of saying, okay, that's fine. And then, of course, we can also do security checks. So if you go and try to deploy something, or if you would like to deploy something on a domain where you really need to define a certain type of security parameters, then we can also check that that is done and it's not missing, and then we can provide feedback on that. And just to give you a brief example of how this looks on Bitbucket, here we have an example of how it looks when a pull request has been created, and the validation checks have, or the governance checks has seen that there is a stakeholder that needs to review this, have to look at it, and that's what we see down on the left-hand corner, that a user was added. And here we have an example of the code insights, the reporting. This pull request where the checks have passed, and then there are some extra information on what might the user does the user have to do to successfully expose the API. And here the user needs to make sure that some specific upstream credentials are in place. Otherwise, the API gateway cannot authenticate towards the upstream system. And here we have an example of a failed pull request. There's basically just some properties missing, and if you click on that message, you will see the file where the problem is. So this is a way we can give very fast feedback to the users, so that they don't have to, that we can catch the obvious errors very fast, and also some not so obvious errors. And that combined with the documentation that we give to the users, give a much better or much more convenient flow. And that basically is for us developer happiness, right? So what we have so far is that we empower the users to take control of their work on their terms, instead of having to wait for other teams, so that they have, when they have the time to process your request, then they will give you feedback, and of course they're happy to do that, but you have to wait in the meantime, and then you are not focusing on what you wanted to do. So we have empowered them in this way, so that by moving basically from this centralized workflow to a decentralized workflow. And this reduces just the entire cycle from idea to production quite dramatically. And as I've already said, this means that the developers can spend time focusing on their jobs instead of focusing on the complex tasks. We saw all the resources that has to be provisioned. They don't have to worry about all this stuff. How do you expose an API on the technical side? And they can just focus on what they really want to do and get that work done. Of course, so right, that's a pretty big thing. I mean, just thinking about reversing the workflow like that. But of course, there are still things to improve. For instance, you might have thought about this. There's still someone somewhere that has to approve the pull requests, and that takes time. You're waiting for that, right? Of course, not in the development stage, but on the production stage, someone has to still approve it. And we want to work more towards that we can actually do all the checks automatically. And that's, of course, we can only do together with the stakeholders that they give us basically buy-in on that we do the checks properly. But that's where we want to go. So basically, if your API definition is okay, then the checks will go, will run, and then the pull request can be merged by yourself, or it's just automatically merged. But we're not there yet. And also, we don't live in this bubble where we can only do, let's say, well, OAuth 2 enabled applications or only REST APIs. We also have legacy systems, like in every business, not only big ones like Helvetia, and I think even small startups, after a year, they have legacy systems. And we have to take care of them as well. And that's something we're working on as well to support SOAP. And also then we have to handle the entire authentication with SAML tokens and ES security. So that's some of the things we're going to tackle in the next time. And this is then also not the end, right? Because we've just talked about exposing APIs, but that's just a single process or single workflow that a developer might worry about. So other things that you might want to create a GitOps solution or self-service concept might be for some of the following things. Kafka topics, we actually have another solution there already. Atlas MongoDB, S3 buckets, RDS instances for the identity provider, doing OpenShift cluster configuration and monitoring, SignalFX, one of the tools we use there. Actually, monitoring we want built into the API exposure self-service as well, so that when you've exposed your APIs, you have end-to-end monitoring. You just get a link to your to a dashboard, and then you see you can go and see how they are doing. And this, I think, wraps up our talk. Well, thank you very much for your attention.
And now I think it's time for a couple of questions.
So, thank you, Lars and Basil. You were really on time. I heard the timer run out. I'm officially impressed. Yeah. So, let me ask you some questions. I need a name for Anonymous. Okay. So, I think this is Mr. Anonymous. Yeah. Mr. Anonymous wants to know, what do I need to move to DevOps? I have a programming background.
What's the question?
The question
What
is,
or why?
what do I need to move to DevOps? I have a programming background.
Well, I think that's quite easy in a way. You can just go to a company where they want to start a DevOps culture. So now that's a little bit on the, I don't know, you have to be in a setting where it makes sense. And then also be interested in the ops side, maybe. I think that's if you're motivated to learn it, I don't know. I haven't read any books, but you might.
Well, yeah, I can just share my own experience because I did exactly that way, right? So I used to be a developer only writing Java code. Mm-hmm. And at some point it became just very obvious to me that just having that beautiful formatted code with all those perfect patterns in there doesn't really make sense until that code is shipped to the user.
That's true.
And so I was just starting to look at, okay, what is needed in order to get the application deployed to a production server? And with the programming background, you're not doing that in a manual fashion. You always think about, okay, where is there room for automation? And I think as soon as you start thinking like that, you're already moving towards that DevOps idea.
Yeah, and I think I had a similar experience. I was in my own startup also for some years where, so as a developer, you also have to ship products, you have to do a lot of things. You don't just get to program, but when you are a programmer at heart, you automate everything, or at least as much as possible up to a level, and then you don't care anymore because there's no pain points really there. And then, yeah, so for me, that's just a natural transition really.
It's because we are all lazy, or at the end of the day, and DevOps helps us automate that stuff.
Yeah. There is, I think, it was Douglas Adams who wrote about how he loved to, back in the day, to automate, spend an hour automating something he could have done in 5 minutes, manually.
Yeah. This sounds like Douglas Adams. So, and Mrs. Anonymous wants to know why Bitbucket?
Well, that's before my time at Helvetia, so I can't answer that, but maybe you know.
I can't really give the answer, but I think it's interesting because there are always some constraints, right? And in our case, the constraint is that Bitbucket is set as the tool of choice for managing Git repositories. So I'm pretty sure if we would go out there and do an evaluation of like modern Git management tools, the winner might be a different one, I don't know. But in the end, that's not really important to me because you just need to accept that you always have some boundaries, that you always have things that you can't change. And it really helps if you just accept that and incorporate that into your solution and try to do the best with it.
And also, if you take a little bit, maybe a little bit a higher perspective, Bitbucket is and even Git is almost irrelevant here. in this conversation. We could have actually chosen a document database, something, and a different user interface. We could have built something ourselves. It's all about storing immutable information and having this single source of truth. And that doesn't really have to do. It doesn't have to be Git. It's just something, right? And in our case, we have Bitbucket works, and for now we are using this pull request flow because it gives us a lot of value immediately. But you could imagine in the future that we might create a more, let's say, user-friendly flow so it's not only developers that have to work with it. But yeah, so Bitbucket is just a circumstance.
Yeah. I would like to extend that question to a certain amount. Do you think that when it comes to something like GitOps or whatever you call it, does the tool make a difference, or is the process and the living of the process actually the more important part?
I give my own answer. Mm-hmm. From my perspective, it's definitely the process. I think we constantly overestimate the importance of our tools, but that's basically just my opinion on it. Maybe it's also to protect myself from being frustrated too much, because, as I said before, I think in every situation there is something you can't change, and it just helps me if I try to focus on the things that I can improve.
Hmm. Yeah, I completely agree. It's more the process. I mean, the tools are good or great or something in between, but a lot of the times at least in a larger setting like Helvetia, you can't really pick and choose like you would like to. So you have to compromise with it.
That's true. So, and here is Niket. Niket is back. Okay. Hi, Niket. Niket connected with me on LinkedIn yesterday. It was very, very attention and question producing. Question 1, how do you choose which workload to run on OpenShift and which one on a public cloud like AWS or Azure?
Well, I'd say in general, the container platform, so basically OpenShift is the desired place to go to if you don't want to really make the decision, right? Because that's becoming more and more the de facto standard here for applications. But in our case, we just found out that certain things just don't make sense to run them on OpenShift. It's because we want to leverage specific functionality that is provided by, in this case, AWS, which is, for example, a very good DDoS protection that we get by that. We're also moving some of these API gateways over to Amazon for better high availability cases. So I can't really give here a recipe of how to make the decision. It's like with almost every other technical decision that you have to make. You just need to identify what is really important to you and where is the best solution.
I think, as you said it quite well, that almost the default is OpenShift, right? So to decide is basically if you have other needs than that as a developer at Helvetia. And most projects fit well into the OpenShift platform, the container platform that we provide. And that's fine and good for most. And then we have to manually or on a case-by-case basis evaluate if something else makes sense.
Makes definitely sense. So, and Niket also gives you a great kudos, great technical session, best of the day.
It's the first one, no?
He's also
thank you.
He's also very funny. Okay, then somebody writes, the moderator rocks, he's asking very smart question. Am I reading the questions or am I asking them? Okay. So, but Niket also has a second question, which looks interesting. It's also a lot of text. How do we link specific API to an application or a code? Is there an API table, API database? What is the URL inside the API definition refer to? Is it the destination? This is a lot of questions. Let me start at the beginning. Okay, they want to know how to link the specific API to an application or code.
Yeah. So I think I glossed over it quite quickly, but he saw, was it Nick?
Nicket, yeah.
Yeah. He noticed that there was a URL in the OpenAPI version 3 spec, and that is the upstream, that's the URL of the backend service. So the internal URL that we route the traffic to from the API gateway when the requests come from the clients through all the other layers to the API gateway, and then they go to the URL specified in the OS3 specification. So that's the link between the two.
Okay, so this is also where the next question is already answered. Is there an API table, API database, more or less?
Yeah. No, it all comes from the Git repository, and that's what we wanted to achieve, that we can recreate the entire system based on the information in there. It has to be complete.
Okay, perfect. So, next, Manu DevOps wants to know, is it possible to adopt GitOps for your Android app and deploy it on Google Play for free as a developer?
No idea.
No idea.
Me neither.
Sorry. Don't think I can answer that one.
But I mean, I can give a very general answer. I think, as Lars tried to explain in his last slide, it's a lot about thinking about that concept of defining in an immutable way the infrastructure that is needed to get something up and running. And now I can't say what is needed to get that application up and running in Google, what was it?
Google Play, I guess.
Google Play Store.
Google Play.
Yeah, but in the end, if there is an API for the Google Play Store, I can easily imagine that you could come up with a solution that does something similar with the Google Play Store.
So, and then again, the question is, does it make sense? So, where it makes sense for us to do something with a GitOps approach is if you, let's say, you have a lot of things that you want to manage. If you, let's say, you just want to put a single application onto the Google Play Store, maybe it makes sense. I don't know, but because it's also a lot of work to set it up.
I think
exactly.
Manu DevOps has to find it out, or?
Sorry, I didn't get that.
Manu DevOps has to find it out himself and let us know in a talk next time.
Yeah, that would be great.
Okay, so we're running out of time, but I think it's okay to ask a very last question. So before the very last question, Abdilaila says, thank you for the talk and the big picture of the functionalities of GitOps. And there is a last question, one which I think I will forward you because it's a big question, and maybe we do this in a different setting from Caleb. But a last one from Anonymous. How do you handle legacy code overall in your sprints? I think this is because you mentioned legacy code before. So
Well, I think that's also a little bit difficult to answer because it's a general question, right? So what do you want to do with legacy code, which is of course open, but point of view, after code has been written, it's legacy. it's then you have to deal with it, you have to work with it, you have to maintain it. So for me, there's not so much difference between code that I wrote yesterday and code that I wrote 3 years ago. When does it become legacy? It's just something, it's a label we stick on something because we think it's scary, I think. And maybe the code I wrote yesterday is not scary to me, but it's maybe scary to Basil. Yeah, because he hasn't seen it. That's even worse than not having seen it in 3 years. He has never seen it before. Yeah. So for me, there's not really any difference. That's probably not a very useful answer, but that's my point of view.
Okay. Basil and Lars and Basil, thank you for your presentation and for your stamina to stand for the whole presentation and questions and answers. I hope to see you sometime in Switzerland. Until then, thank you. And for the audience, we'll have a small break and then we go into the next talk. Oh my God, so many talks. Bye.
Thank you. Bye.
There we are again. After we learned everything about GitOps, or at least the basics, and we know now how we can go about with this thing with Basil and Lars. Believe it or not, we did not leave Switzerland. We're still in Switzerland. And next up is Nico Martin, who will tell us something about progressive web apps. The next big thing. Are you excited? I am. So I will roll the intro now, and then we'll meet Nico. Hi, Nico.
Hi, everyone. So yeah, my name is Nico. I'm a web developer from Switzerland. I'm mainly focused on front-end development and JavaScript. I'm also 1/3 of Say Hello. We are a small digital agency here in the Bernese Oberland, and I do freelance stuff from time to time. Right now, I'm, for example, working on a quite large React application. Yeah, and today it's all about progressive web apps. In my opinion, the next big thing in web development or in development of digital products in general, I'd say. The whole subject is quite large. So today I really just want to dip a toe into some of the most exciting features. And to start with the whole idea and the whole idea behind progressive web apps, I'd like to talk about the web first, because the web is great. It's, in my opinion, I could even go as far to say that the web is one of the greatest achievements of mankind, because we have this global network of servers. They're all connected to each other. They are all accessible through the domain name system, and we have browsers. So we have those standardized programming language. We have HTML for the markup. We have CSS for styling and layout, and we also have JavaScript for the whole logic behind our application. And those languages are not just some new languages. I mean, the biggest companies in the whole world are working together on this one platform. So we have this idea of a free and accessible platform to share information and also to deliver applications. And I think that's just huge. And then we have apps. And I mean, apps are great as well, especially the smartphone is great as well. And I mean, around, I think 2007, the iPhone was published. And a little bit later, they also published an SDK. So that allows us as developer to an excessive access to the operating system. So we can just add, or we can create applications that interact with the operating system. And to be honest, back then, the web was just not ready to be used on phones. They had a web engine on the phones, but there were so many things missing. So the SDKs, they stepped in and they delivered a great experience for us as developers and for the user. Problem is, if we are creating a native application, we are bound to what the vendor gives us. So in the end, if Apple decides to deliver a feature, we can use it. If not, we just can't use it. There is not this platform-wide working together of those companies. It's just we are dependent on the vendor. Also, we need to maintain the same software for multiple platforms. So even if we are using cross-platform frameworks, we still have to maintain 3 or 4 different versions of our application just for our product. So that's insane. But we need to do it because of statistics. 87% of the time we spend on our phone, we are inside mobile apps. That's it's a little bit older, but I think that's still a valid number. So in the end, we need to write native applications because the user wants it, but it's quite a pain to create them. So we are in this little, you do have this problem as developers. So there were a team of mainly Google developers. They were looking at that problem and they were thinking, or first of all, they were looking for the reason why are native apps so much more popular than the open web. And they found out that there are mainly 4 things that make mobile applications so much more popular. They're fast, which means once you've downloaded them, they are on your device. You can use them. You can click on the button and it's just there. They are integrated, so they feel like a part, or they feel like an extension of your operating system. They are reliable, so even if you don't have an internet connection, you still can work with that application. Maybe there is a message saying that you need active interconnection, but it's coming from that application. You're interacting with that application and not just with some browser error. And they are engaging. So it is possible to pull the user back, maybe using push notifications, or I don't know. So they had this idea of a next generation of web applications, and they called them progressive web apps. So to achieve what they wanted, they needed two new main functionalities. And the first is the web app manifest. As you can see there on the right, it's pretty easy. You just need to have a new meta tag called the rel manifest, and there you can just pass the path to the manifest.json. Could be any JSON file, and in there you can define a set of properties for your application. Maybe a name, a short name. You can define where should it start, and so on. So it's just a set of information you can give about your application. Now on the left side, you see the browser recognizes your application as a progressive web app, and it allows the user to add that to your home screen, or to his home screen. You can click on this add to home screen. I mean, now it's a little bit different. The current banner is a little bit smaller, but still it's the browser that decides when to show this banner. If you click on it, you will ask do you actually want to add it to your home screen? And if you want that, you have this to-do progressive web app right next to all the other apps like SPB, Chrome, whatever. Even if you open the task manager, you see that your app is right next to all the other apps. And the interesting thing here is that your progressive web app is there right next to Chrome, but in the end, the progressive web app is still a web application. It's still just a different view of the thing that Chrome shows you, and it's there as a separate application. Also, if you open it, you will see that the URL bar is gone. So in the manifest.json, you see the display is set to standalone. That means that we want to have our app to take over the whole screen, and the URL bar is gone. There are a set of other APIs that try to give this integrated feeling, and they are mostly under this umbrella term Project Fugu. Project Fugu is a cross-organization project. So it's I think Google, Microsoft, Samsung, and some guys from Apple maybe as well. They are working together on a set of new APIs that you can use to give an integrated feeling for your applications, for your web application. For example, we have the Web Share API that allows us to share, to send information to the native share prompt. We have the Share Target API where we can receive content that is shared over another app or another web app. We have the Media Session API where we can control the media thing, or the media controls of our device. We can use the Contact Speaker API, and there's a whole lot of new APIs that are coming or that are already in the browsers we are using, and most of them are quite fun to use. The next thing is offline availability. So the whole idea of having an offline application is that we should treat the network connectivity as a progressive enhancement, which means that it's not required to use your application. That's the goal. Of course, if you want to, let's say, if you want to see new emails that has been sent to us, we need to have an active interconnection, sure. But we don't need an internet connection to read emails we have already downloaded before. So that's the thing. There are several ways to store information in our browser or on our device. There is cookies, there is the session local storage, and there are also two new things, which is the service worker storage and the indexed DB. And we will look at this in more detail at both of them. So if we have our application, let's take a normal single page application where we have maybe an index HTML, we have some application JavaScript, we have some styles, we have some assets. Those are static files. That's the app shell around our application. Then we have dynamic data, which is data that comes from an API. And the whole difference is that the static files don't change. If we have, let's say, a new version of our application JavaScript, we would have a new hash for the new version or something like that, but still the JavaScript shouldn't change, while the dynamic data will change very frequently. As soon as we create a new blog post, we will have different content inside our post endpoint. So that's why we treat both of them separate or in a different way. Let's start with dynamic data, and therefore we have a very powerful thing in our browser called the IndexedDB. The IndexedDB is a non-relational database inside our browser. So it's basically just an object store where we can put data and where we can get data from. Problem here, it's a pain to use. The API is probably one of the worst APIs we have in our browsers. So that's why there is a pretty cool project called IDB, which is in the end just a promise-based wrapper around the IndexedDB API. And that makes it quite cool to use. And why should we use IndexedDB versus maybe something like the local storage? The whole thing, IndexedDB is designed as a database. So we can store a large amount of data. It's all asynchronous. So all the requests run asynchronous. And last but not least, it provides indexes. Let's have a look at how it's implemented in our, or how IDB, the wrapper around IndexedDB works. Here we have our store. We create a store, could be any name you want. Inside our DB, we create a store. Then we have some methods on that store. We can get information out of it. We can set information. We can delete everything. And then we just call IDB set. So if you have a post and we want to save our post inside our IndexedDB, we can just call idb.set with a key and the value. The value could be a string, could be an object. Everything's possible. And we can then also get it from the IDB using IDB get. So that's pretty cool. And the whole thing why we have IndexedDB for dynamic data is if we work with data, it's mostly we work with it inside our application logic. So we decide, hey, we want to have this post, and then we can decide, yeah, let's take that post from the endpoint because we have an internet connection, or we can say, no, we want to take it from the IndexedDB because it's already there. So it's on us to decide. With static files, it's a little bit different because mostly it's the browser who decides when and why and how it will fetch a static file. And maybe we have the index HTML, for example. If we hit enter on a URL, it will fetch the index HTML file, and we can't control. We don't have any control over that. So we need a new technology, and that's the service worker. So the service worker is also JavaScript. We have JavaScript here. I'm just using Wikipedia, and maybe we have some JavaScript already. And I mean, JavaScript has become a very popular programming language. It started as a simple DOM manipulation language, and now we have this fully featured language. But we still have one problem. As soon as we close the tab, or as soon as we close the browser, the JavaScript is just dead. So we need a different scope for our service worker. So it's, as I said, still JavaScript, but it lives not inside our window scope. It lives in a separate scope between the browser, or between the website and the browser. And it lives there. That's the most important thing. It lives there forever. So it won't just go away if we close the browser. How do we do that? We have on the navigator.service worker, we have this method called register. There we can just add a path where our service worker is, and we can add a scope. So we can have different service workers for different parts of our web application. And inside our service worker, we have some events, for example, the install event. We have the activate event once the installation has finished. We have the fetch event and we have the push event. And we will look at them in a minute. So in the end, we have this life cycle, a service worker. If we call the register, it will be installing, then it's activated. And after we close the window, it's idle. It's not gone. It's there and it's waiting for something to happen, but it's idle. It can also be terminated. So if the browser, or if you kill the service worker inside the browser, it's terminated, or it's also redundant. So if you have a new version of your service worker, it will just be replaced, or the old version will just be replaced and it's redundant, while the new service worker will take over. In the end, the service worker is registered in the browser, lives there in a separate scope, has its own event system, and most importantly, it remains active even if the page or the browser is closed. Now, offline availability with the service worker. Again, the same example. We want to see wikipedia.org. We will go to the URL. We will hit enter. It will go through the network to the server. It will answer with the index HTML we want, and it's all fine. We have it. The problem, if we have no active internet connection, there is nothing the browser could show. So it will just show this very ugly network error page. With the service worker and the application storage, we have this new source. So if you look at it, we have the website and we have the network, and between that we have the service worker. So each request goes from the website to the internet through the service worker, and also when it comes back, it goes through the service worker. And that's the important thing, because if we don't have an interconnection, we still have this reliable source, the application storage. So we can put a copy of the request to the application storage, and next time we can just take the version from the application storage, and that's pretty cool. How does it look in the code? We have this fetch event I've shown before, and inside this fetch event we can just interrupt the whole request. So what we are doing here is instead of letting it go through, we will take the event and we will then respond with something else. So in this case, we will just respond with a new response, an index or an HTML file saying hello world. That means each request from the website to the network will return hello world. That's all it does. Not very useful, but if we look at the next example, there we have two events. First, when the install event happens, so when the browser tries to register our service worker, we will wait until we added this cat.svg. So as you see here, we take the event, we will call wait until, which means that the whole activation will be delayed until the wait until is done. We will open a new cache called static images. If that's open, we will just add a new image. It will go to the network. It will take the cat.svg and it will put the cat.svg to the static images cache. Next time, when we have a fetch event, we will just check if the path name is cat.svg, because if so, remember we added it to the cache, so it will be there. We can just respond with the cat.svg. That means in this case, it won't go to the network. It will immediately respond with the thing it sees in the cache. And that's instant because there's no network latency. It's just, it will take the thing from the cache and it will return the cache. So we have the service worker and it's sitting there and will just do what we want. A very useful example is images. in most cases, we don't want, or images are quite heavy, and it doesn't make sense to download those images every time we look at or the user visits our page. So what we do here is we call the fetch event. We will then check if the URL ends with PNG, GIF, JPEG, SVG, or icon. If so, we will call this respond with. We will look into the cache if there's already a cached version of this image. If so, we will return this. If not, we will fetch the image. We will create a copy. We will add that copy to the cache, and we will return the response. So the first time it will go to the network. Second time it will just be returned from the app cache. It's quite similar to how the browser cache already works, but the big difference here is that we have control over how this caching works, and it's not the browser that decides, yeah, I want to do that or I want to do this. Also for the service worker API, it's quite sometimes quite complicated to use. So therefore, there is this tool called Workbox.js, which is a JavaScript framework provided by some developers from Google. And in the end, it's just super easy abstraction of the fetch event. So the whole code we've seen before, written with Workbox, will just be, we can register a new Workbox route. We can pass the regex, and we can then create a new strategy, cache first. That means go look at the cache if it's already there. If not, go to the network. So it's just very easy to use the fetch event with Workbox.js. Now, is this store or the storage we're using, is it really persistent? And I mean, you could imagine if more and more websites are using stuff like the service worker and the application storage, your browser or the space you have in your device will pretty fast be full. So of course, the browser needs to manage the space it has. If you want to make sure that your application or the data of your application is really persistent, we have the persistent storage API. We have, for example, storage.persist, which will check if which will ask whether the browser can persist our data or not. And we have navigator.storage.persisted that only checks if the storage of that website is persisted or not. That means we have our protected data from, let's say, the data from the cache API, from cookies, from IndexedDB and service worker. If the storage is persisted, all those data is protected. And the implementation in the browser looks like this. Chrome, if you call storage.persist in Chrome, it will just check if there is a high level of site engagement, and it will decide on those metrics whether it will be persistent or not. And in Firefox will just ask the user with a little prompt, hey, do you want to allow this website to add persistent data? In Safari, currently it's not supported. So, and the last feature of today is push notifications. I think every one of us uses push notifications on a daily basis. Why? Because it's just the implementation of the Hollywood principle on our device. In Hollywood, there is the saying, don't call us, we call you. So I think when a lot of people moved to Hollywood to become a famous actor, the agencies had a lot to do with just answering calls, whether someone got the job or not. So they said, hey, don't call us, we call you. It doesn't make sense. If you talk about the messaging application, it doesn't make sense to open up the application every 5 minutes to check whether you got something new or not. We want to be informed whether or as soon as something important happens. And that's just why we use push notifications. Also for a developer or a marketeer perspective, it allows us to very precisely target users to deliver specific content to a specific group of users. which in the end will create a better conversion rate, and we are able to add real value. So we can inform users about things that happen that actually is a value to them. Now let's look at the implementation. That's the easiest thing we want to achieve. We have our application backend and we just want to send a notification to that client. The problem here is, as we've seen before, as long as the user is not using our site at the moment, there's no way for us to interact with that user as a backend. So we need to have a service in between our backend and the client. And that's the push service. And if you are developing mobile application, I'm pretty sure you are familiar with those push services. Each device or also each browser has its own push service. So there's a Firebase cloud messaging for Android and for Google Chrome. We have Mozilla push service for Firefox, and we have Windows notification service for Internet Explorer. And there's also Apple push notification service, but there are some problems with it, and we will get to that at the end. But we can use this push service to send push notifications to the client. Now, first of all, how do we know where to send the push notification if we want to reach out to, let's say, user A, first thing. And second thing, how does the push service, or how can we authenticate at the push service so the push service knows that we are actually allowed to send the push notifications to that client? That's the two problems we can solve with Vapid. Vapid is called, or is short for Voluntary Application Server Identification. And in the end, it's just a public-private key pair we have on our application backend. So we have our public key, we have our private key, and we can send the public key down to the client. On the client, we will then call the push manager from the push API. And with that push manager, we can create a so-called push subscription. So first we will need to get the service worker registration. With that service worker, we can then subscribe to or create a new subscription. And there we pass the application server key, which is the public Vapid key. And if we have that subscription, we can send that subscription that consists of an endpoint and some keys. We can send that to the application backend, and we can save that inside the DB for that user. So if you want to send a push, we can send the encrypted data to the endpoint we have from the push subscription, and we have the private key to authenticate against the push service. So with the private key, the push service knows, okay, we are authenticated. With the subscription, the push service can verify that we are allowed to send a push notification, and the push service will then forward it to the device. And that's through the HTTP web push protocol. Thing now is maybe our website is we are not using the website at the moment, which would be the normal case. And that's where the service worker steps in. So inside our service worker, we can listen for the push event. We can extract the data from the payload, and we can then show the push, or we can show the notification on the client. And if you click on it, maybe we can just open up our web application. That's the whole magic behind push notifications. There's one problem. If we want to create a push subscription, we need to have the permissions. So what you see here is a newspaper from Switzerland, tagblatt.ch, and what they do is they will just ask upfront if they can send push notification, and that's just the worst thing you can do, because the user has no idea about the context. Maybe someone just visits your site coming from the social media platform, and he wants to read an article, but the first thing is this strange pop-up that asks for any permission, and of course you will deny that. There are solutions already. Browser vendors are working on a quiet push notification UI, so it's not that prompt that needs a decision right now. It would be a quiet push or a little bell on the URL bar. Or there are also, and that's in Firefox from 72 and in Chrome from 80 on. But we as developer, we can do better. So whenever we ask for any kind of permission, we need to think about the user experience. We can ask for a permission. We need to ask for permissions because that's the way the browser knows that the user is actually that the user actually wants to receive push notifications. But we need to create a seamless UX where we can prepare the user and we can tell him why and how and all the things work before we ask for the permission. So that's it from the technical side. Now I have one example with me. What you see here is the refugee camp Moria in Lesbos, and it was built in 2015 for around 3,000 refugees. It was planned for 3,000 refugees. Currently, there are more than 12,000 refugees, and the highest number was, I think, around 20,000 refugees. A good friend of mine, Tim Schoch, was there to help as a volunteer, and he is a UX designer, and he quickly experienced one big problem, and that's the communication. If you have a camp that was built for 3,000 refugees, and now you have 12,000 there, it's just really, really hard to communicate with them. Why do they need communication? They have everything they do in the camp is around a ticketing system. So if anyone needs a special or has special needs, he will request a ticket for maybe see the doctor or maybe have new diapers, whatever. And it takes time to process that request. So mostly you have a lot of people waiting in the forecourt of this main building, just waiting for their ticket. So it would be nice if they had the way to inform someone if the ticket is ready. Also, of course, with COVID-19, it's very important that you have a way to inform everyone about new measures, about things that happen in the camp. And so we had this need to create something, and we did. So what we created for Euro Relief, which is the organization behind Moria, is you created a backend in Node.js, TypeScript, and MongoDB that's just responsible for the authentication. So a refugee can authenticate there, and we created a front end. I created it with TypeScript, React.js, and PostCSS. In the end, both back and front end are open source. So and also my slides, I will share them later, so you'll have the links. Everything we've done there is open source and can work with it if you want to, or can have a look at it. And the whole thing, why we wanted to create a progressive web app is that with this, we had an integrated experience with a very low entry barrier. So it's always a little bit of a problem of the trust between refugees and the organization. So they don't have to install anything. They can just use it. They can add it to the home screen, but they don't have to add it to the home screen. It works offline. It's extremely small. I think the whole bundle is around 100 kilobytes broadly compressed. And even then, that's only downloaded once. And then it's persistent, stored inside the storage, and all the data is inside the IndexedDB. We have push notifications. So the organization can send push notifications to one user or to all the users. And we also have a SMS fallback. So if the push doesn't work, it's still possible to send an SMS as a fallback. And the best thing, we have very fast release cycles because we are not bound to the store. We can ship new features within hours. I think the the first prototype of the application, I've built that in around 1 weekend, and it took us 4 weeks to have the first beta. And everything we did was just, we could ship everything to the organization just to show where we are and to get feedback from them. And that's pretty cool. And you couldn't achieve that with a native application. One little thing right now, maybe you heard it in the news, the 8th of September. No, sorry. Yeah, September. There was the first confirmed case of COVID-19 in the camp. Just the day before we launched the application in a beta mode. They had a quarantine for part of the camp, which then led to a lot of lot of problems, and in the end the whole camp burned down, which is a very, very sad story. And right now the problem is there is a temporary refugee camp, but the conditions there are terrible right now. So if you want to help, there is a GoFundMe campaign where you can help to rebuild the camp and everything. And of course, our application is now on hold because they don't even have electricity right now. It's just terrible, the conditions there right now. But I think, I mean, what you have seen with this whole riots is that having a way to interact with the people is a critical part of the whole organization. And I'm not saying that our application could have prevented that, but it just would have been nice if they had a way to inform them properly. So now for the end, I know we are running out of time. A little bit about the browser support. Installability is supported by all major browsers. Even Safari has some kind. You can add it to the home screen and it will also respect the display mode and everything, but it just does not work the same way as on Android. And in Firefox, it's behind the flag. The service worker is supported by all major platforms, including Safari, and now push notifications, and that's the biggest problem right now. Push notifications are only supported by Edge, Firefox, and Chrome. Safari currently does not support push notifications or web push notification to be more specific. And the problem here is there is generally a very difficult relationship between Apple and Progressive Web Apps. They make very small steps towards Progressive Web Apps. So also for the Service Worker API, it took them years to decide whether they want to support service workers or not. They did. And back then it took them only several weeks after they decided to actually ship service worker support. Right now, there are no signals whether or when they will support push notifications. And the biggest problem of all is that iOS has this super annoying WebKit constraint. So all the browsers you have on your iOS are powered by their own engine. So Google can't just ship a fully featured version of Chrome. It's still a WebKit version of Chrome with all the lag they implemented. There are some petitions. If you want to sign them, I have the links here. If you want to address other bugs you have with WebKit, it's great if you can add your use case. So I really hope that Apple will one time realize how bad they hold back the whole web ecosystem. But yeah, in the end, it's just a part of their whole mentality that they want to support their own app ecosystem instead of the open web. Yeah, with this, I will end my talk. Thank you very much for your attention. If there are any questions, I'm happy to answer them. I know we're a little bit over time. So I'm also very active on Twitter. So if you want to, if you have some other questions, you can also hit me there. Thank you very much for your attention.
Thank you, Nico. Amazing talk, very inspirational. Yeah, let me get one of the things which came in like some minutes ago. Kudos for everybody on the team of the Euro Relief project. So this also goes to you and to
Thanks.
everybody out there. And so now let's come for the technical questions.
Mhm.
What is your opinion on frameworks like Electron?
I acknowledge the need of it. Let's put it like that. I think it's great if you have that framework where you can ship applications regardless of the platform. But the thing is, we already have the thing. We already have the browser, and there, in my opinion, there shouldn't be a need of creating a wrapper around that application where you have then maybe standards, web standards, or other standards. If we come to the point where the browser has all these features that Chrome and also Edge and Samsung are working on, there's no need anymore to create Electron applications, because I think the Electron framework is quite huge as well. And if you think about the Moria app, where we had, or I set the budget or the data budget on 100 kilobyte, it's not possible to create an Electron application. I think Electron alone is more a couple of 100 kilobytes. So right now we need it, but I really hope that we don't need it in the future anymore.
Okay. Thank you. So then the next question from Sunny, you already answered. Asked, does this all work with all browsers and operating systems? You had the charts there.
Yeah, one thing there. Yeah, some APIs, they work with all browsers, but not every API. But the cool thing here is the whole term progressive really means that we can use APIs that might not be available on all browsers, but we can use them wherever it's possible, and where not, we can either create a fallback or we can just leave it because it's not a critical part. If we talk about push notifications, okay, I get it. That's a critical part, and maybe we need to have a fallback or anything like that. But if we take, for example, the web share API, it's nice to give the user the possibility to share content to that application or from that application to another application, but it's not a critical part of the app. So the cool thing here is that in most cases we can use them even if that's not supported by all operating system and all browsers.
Thank you. So it's again the Mr. and Mrs. Anonymous. What would you suggest to do if I want to dive deeper into PWA? I guess you just gave us a short but very nice intro to the topic.
Well, one thing, I've written a little demo progressive web app, which is this to-do progressive web app I've shown you in the right in the beginning. And I've written the same application in Vue.js and in React.js. So that would be maybe a starting point if you want to know how you could implement features to your application. Doesn't matter. I'm not a big, or I don't have any experience with Angular, so it's not in Angular as well. It's just Vue and React. But that could be a starting point. And if you want to know more about the whole philosophy behind that, I think there are very good articles on web.dev, because it's mainly Google that pushes the whole progressive web app thing. So there's great resources there as well.
It's over for me. It's always funny when I hear progressive web apps, and now Google is pushing something which I guess was made like a mainstream topic by Apple back in 2007, where progressive web apps were the only apps on the iPhone ever before they launched the App Store. It's so crazy.
Yeah, that's a funny story, because as you said, when they launched iOS, they didn't have their SDK ready, but they had a fully featured browser. So they were already using a WebKit browser on iOS, and they were the first that had a fully featured browser on a smartphone. So I think it was Steve Jobs who said that, hey, you can create a fully featured web application for iOS and it's all great and everything. But then came the store, the SDK, and then they found out how many millions that they can make with just having everyone using, or with restricting everyone to the App Store. And I think this whole thing wasn't that exciting anymore for them.
Yeah, it seems like, yeah.
No.
Oh, so another one from the Anonymous SS. What's your most favorite use case for service workers?
Right now, it's I think it's for the application storage, so the app cache. So having the possibility to intercept network requests and to have strategies like you can decide whether you want to first check the network and then use the application or the storage as a fallback, or the other way around, where you can just look if that request is already in the store. If not, go to the network. It just, if you have the right strategies to cache your content, it makes your app so much faster and so much more reliable, even if you have flaky or unstable Li-Fi. I love this Li-Fi. How do you call it? This term Li-Fi, because if you have internet connection that's not quite good enough to show the application and it keeps you loading and waiting, you could just get over it with the service worker and just say, well, if there is no, or if it takes too long to have a response from the network, just answer with something you've already stored inside the application storage. So I think that's, for now, that's the most exciting feature. Also because that's working on all platform, on all browsers, and yeah.
Cool. And Statis, I think I've read some questions from him or her. Just from curiosity, if we kill the cache from time to time, do we lose the worker's functionality?
If you just make a hard reload, let's say if you just want to delete the browser cache, it won't affect the IndexedDB or the application storage. But if you actually delete all data assigned to that URL or to that property, it will also delete the application storage. But that's the same if you would go to settings of your application inside your smartphone, and then you would open up the app settings and you would delete all data there. That would be the exact same thing. The cool thing is, even if you delete all data of your application, you would still be able to use your application with the network, because in most cases you have either the network as a fallback or the application storage as a fallback. They play together quite nicely. So if you only press hard reload, it won't affect the application storage. It won't delete the service worker or anything. But of course, if you want to clear all data, that's also possible, and that would affect the functionality of your site as well.
Okay, and then there is another question from Statis. So the backend knows how to sort notifications and send them to specific users using the public-private key combination.
Kind of. The public-private key combination is just, you need the public key to create a push subscription. And the push subscription has a endpoint, which is a URL. So if I want to send a push notification, I have the subscription, and I'd need to store that subscription to my user. The best example is if we take a messaging platform. We know we have user A, and user A is using our platform, and he created a subscription, and we can take that subscription and store that in our database to user A. Now user B wants to send a notification or wants to send a message to user A, let's put it like that. The application backend will then see, oh, there is a new message for user A, and we have a subscription for user A. Great. So we can take the subscription and we can send notification to that URL with all the HTTP web push protocol stuff. But basically it's that we have the subscription and we can send the push or we can send notification to that subscription, and the push service will then forward it to user A, or let's say to the device that has been registered from user A. It's also possible that user A has multiple devices. So your database should know how to handle multiple subscriptions for one user. But that's the idea. The subscription is bound to the client, to one browser, and you would send a notification to that subscription, and the subscription would then, or the push service will then show the notification.
Okay, so there is no actual possibility, or is there a possibility at the moment for the user to sync settings from BWAs across devices and browsers?
No, I don't. At least for the push subscription, you need to have, or each browser needs to create a subscription, but you can't just use the same subscription for multiple devices. That's just not. But I think also, I'm not very into app development, but also if you have different apps, you also create a sort of subscription that is bound to that one device. So you can't just use a subscription from device 1 to send a notification to the device B. You also need to have 2 subscriptions for 2 devices.
Okay, so thank you. This was the last question. We managed to answer all the questions. So
yay.
Round of applause. And I will now roll the loop and be back with the next talk while I take Nico and guide him off the stage so that he doesn't miss the stairs. It's very dangerous in virtual stages.
Yeah, I know.
Hello again. So, believe it or not, there are many things going on in this world. 1 minute before, we have been dealing with progressive web apps, more or less applications on your desktop, and now cloud native applications. So let's roll the intro and go and meet Jens and find out what it's all about. If I can find the button. That's the wrong. So, my colleague gave me the wrong intro, but you are Jens. Hi Jens. Cloud native applications, what's the buzz about? I'm excited. Now I will mute my camera and the stage is all yours.
Yeah, thanks, Stefan. Yeah, hello to everybody. I cannot see you, but I hope that I can share some interesting information for you. I'm today talking a little bit about cloud native applications, a term that has increasingly been used in the last couple of months and maybe even years. But when I started to work with cloud native applications, talk to this topic about, with my clients, I oftentimes had some struggles about, okay, what actually is a cloud native application? And that's what I'd like to talk about today a little bit. First, a few words about myself. So my name is Jens Eickmeyer. I'm living with my family in the northern part of Germany, so near Hanover region. And I'm working for Accenture, or more specifically for Accenture Technology, as a cloud architect and full stack engineer. And in this role, I'm helping our clients to either migrate their applications into the cloud or build new applications on top of cloud technologies. My personal focus in regards to cloud platforms is on AWS. That's what I've been using for the last 5 years plus, I would say. And yeah, currently I'm working for a automotive company to help them to migrate an application from an on-premises cloud environment, so with OpenShift, to the AWS cloud and roll it out across the globe in various regions, which is a pretty exciting endeavor to do. You can find me on social media, LinkedIn, Twitter. I share some code on GitHub, and from time to time I'm also blogging about topics, especially in regards to AWS on my personal blog. So feel free to have a look at that. So let's get started, and let's first talk about what is cloud native. And before we come to the term cloud native, it might make sense to do a step back and talk about what actually is the cloud. And whenever I need to talk about the cloud in general, I come back to a definition that was done by the National Institutes of Standards and Technologies back in, I think, September of 2011, where they defined the cloud back in the day as something that you can use self-service, on-demand self-service, like you can decide to create an email account with Office 365. You can decide to get storage with Dropbox or any other service, but also, of course, with the public cloud providers, which provide you infrastructure like virtual servers, networks, databases, all the stuff that there is. In general, the cloud has broad network access so that you can essentially access the cloud services from anywhere in the world where you have internet connection. The cloud provides the resources that you use. Yeah, not only for you. So there are now the dedicated systems out there where only your data is hosted, only your applications are running. But actually, yeah, the dedicated or the hardware is actually shared across multiple tenants. With the cloud, you get rapid elasticity so that you can scale, for example, your applications automatically as much as you like. You get additional storage as much as you like. The public cloud providers famously state that they have infinite resources, which of course is not true, but yeah, because of the shared infrastructure, it appears to be true. And one important thing about the cloud is that all the cloud services that you can use are most of the time paid as you use them. For example, you pay virtual servers by, I think in AWS, it's in the meantime per second interval. Lambda functions, which some of you might know, you pay in 100 milliseconds intervals. Storage you pay by gigabytes per month and stuff like that. So that's basically a definition I like when it comes to cloud. So what is the cloud? And now when we go to the next step to answer the question, what is cloud native? Yeah, that's a little bit more complicated in my eyes to answer this question. Of course, what do you do if you like to get an answer to such a question? You Google it, and if you Google what is a cloud native application, you get lots of different answers. And I personally did the question within my team: are all people working with cloud applications and the cloud? And again, they all came up with different answers to the simple question, what is cloud native? So I now want to share some examples about definitions that are out there that you can find when you do a simple Google search, what cloud native is. And this first thing I was seeing by myself back in the days when I first came across the term and wanted to find out what this is, I came across this picture from VMware, which basically says, okay, a cloud native application is basically, yeah, on a foundation of 4 different things. You have DevOps, which itself is a pretty broad term. You have continuous delivery. Okay, that's a little bit more concrete. You have microservices. That's maybe a little bit surprising. And you have containers, which is also pretty concrete and yeah, and helpful in a way. But does it mean that you only have a cloud native application if you use microservices and containers and continuous delivery and DevOps? So if you move on and, for example, have a look at the definition of some official entity or organization, you can come to the definition that's a cloud native foundation or the Cloud Native Computing Foundation uses. And they say that cloud native technologies empower organizations to build and run scalable applications in modern dynamic environments such as public, private, and hybrid clouds. Containers, service meshes, microservices, immutable infrastructure, and declarative APIs exemplify this approach. So there again, there are a number of very concrete things like containers and service meshes, microservices that should make up a cloud native application. The next thing that goes in the same direction is from the Linux Foundation. They say that cloud native computing uses an open source software stack to deploy applications as microservices, packaging each part into its own container and dynamically orchestrating those containers to optimize resource utilization. So it already becomes somewhat clear that cloud native has something to do with microservices, with containers, with dynamic environments. But let's move on. There are 3 additional examples I want to bring in. And these examples are now from the 3 major public cloud providers. So let's start with Google. When you do this search on Google about what cloud native means, you will find some blog posts on the Google Cloud blog. And here they mention basically 5 different things, 5 different principles for cloud native applications. One is design for automation. So now we are again to the first picture in this DevOps continuous delivery thing. Be smart with state. This is maybe something new. Favor managed services. Of course, it's Google. They want that you use their managed services. Practice defense in devs. So think about attack scenarios to your applications and harden against these. And maybe one of the things you can do this is by using or leveraging managed services. And always be re-architecting or architecting. So always always try to improve things, right? The architecture, maybe introducing again additional managed services and so on. Next would be Microsoft. And here I found this image in their documentation. And again, there are some pretty familiar terms. They mention microservices, of course. Automation is a big part. Backing services. So in this regard, that's, I would say, the same as managed service that Google mentions, and containers. Modern design, that's some kind of vague, I would say. So what is the modern design? Maybe, yeah, I don't know. And then the last one that I found, and I did it more intentionally because it was easy to find definitions from the other cloud providers. So I explicitly looked for the definition from AWS, and I found some quote from Adrian Cockcroft, the VP of Cloud Architecture and Strategy at AWS, and also a former employee at Netflix who did the whole cloud migration story for Netflix, which I would say is pretty spectacular and successful. So he says that cloud native architectures take full advantage of on-demand delivery, global deployment, elasticity, and higher level services. They enable huge improvements in developer productivity, business agility, scalability, availability, utilization, and cost savings. So again, we find terms that we also seen in the previous examples, like on demand. So this elasticity, they bring in global deployment. Don't know if this really makes sense in each case. Higher level services, again, in my opinion, refers to the managed services that, of course, AWS provides and that they want to use. So derived from these 6 examples that are out there, I would say that the 6 core characteristics, or in my opinion, at least the 6 core characteristics for cloud native applications are that these are applications that are built to run in dynamic environments. So environments where the underlying resources like computing resources or things like that, they come and go as you need, and where you can scale these kinds of resources based on the load that your application actually has. And in order to do this, of course, your application needs to be architected and built in a way that it can cope with this. We come back to some examples about this later in the talk. Automation seems to be a big topic, as we've seen in the past slide, and that's to me also one of the fundamental characteristics of the cloud. That basically the cloud provides you APIs for developers, right? And through APIs you can do amazing things in cloud environments. Like you have tools for scripting your complete infrastructure. You can automate tasks in your operational daily life to do things if certain servers are failing, and start new servers and stuff like that. So the whole automation topic is very important and helps you in this regard. Containers and orchestration are, of course, a term that we've seen in the previous examples a lot. So I would say that containers, or the container technology that we got with Docker, plays a major role in this. Managed services definitely are the case if you run your cloud native applications on public cloud services. Maybe that's not the thing that's so important for private cloud. Decoupling certainly is a thing. So you need to adhere to modern patterns. I mean, they are pretty old, to be honest, but patterns, resiliency patterns that help you to communicate with other systems and plan for the event that these systems are not available and you cannot reach them. And then on the far right side, I also added microservices, but I have my own opinion about whether a cloud native application always needs to be one that is based on a microservices architecture. And if you have an application which adheres to at least some of those characteristics, so it can run in a dynamic environment, lots of things around building, deploying the application, is automated. Yeah, you might use containers and managed services. Then you can leverage the benefits in multiple areas. So, and this is pretty much a standard slide when you talk about cloud and cloud environments, and the benefits that you can get. And I only want to mention a few of those. So one of the things, and that I think that was mentioned in the Linux Foundation definition of cloud native, is in the ballpark of cost optimization. So with this dynamic environment and automation, where you can scale up and down your computing resources based on the load your application has at any given time, you can of course utilize the resources that you have much better, right? Instead of having your server idle at 2% most of the time, idle most of the time, and only be busy at certain other times. You have, of course, not a really good utilization of your resources and of your investment that you put into the computing resources, for example, that you had. And if you can package your application denser on the resources that you have, either in the public cloud or in the private cloud, you of course can optimize the cost for your investments in these areas. Another thing maybe in the cost optimization part is that you only pay for what you use. And this is very apparent if you not only think about running containers continuously or your application continuously, but also switching to things like serverless, where you run function as a service whenever, on demand, whenever you actually need to process some things. If you follow this aspect, that you should use managed services as much as possible, at least when you are on the public cloud. This, of course, reduces your operational effort, so that the effort that you need to take, the time that you need to spend for administrating your infrastructures, your servers, decreases this effort dramatically, because suddenly you do not need to remember to patch your databases or to do something in terms of automatic failover or something like that. And if you use things like Kubernetes to run your containers, so an orchestration framework, you also have some kind of self-healing capabilities, where suddenly if containers are stopped on one server, they are restarted on a different one, and you do not need to have someone get up in the middle of the night to do some things, right? All this automation part, of course, dramatically increases your speed that you have, either when you want to deploy a new application, when you want to get feedback about what's happening in your application and stuff like that. Scaling pays into improving the user experiences. When you are in the public cloud, you can choose from many technologies that you might not use if you would do everything by yourself, famously database technologies maybe. And in the end, with higher level services, so with these managed services that Google, AWS, and Azure provide, you can maybe bring real innovation into your application that you build by, for example, introducing some cognitive services for understanding text, at least the sentiment, or for recognizing objects and images or stuff like that. So there are a whole lot of benefits when it comes to building applications that are specifically designed and architected to run on the cloud. So when we talk about cloud native, and this more or less vague term, where I hope that I could at least shed a little bit of light onto this, you often see common questions coming up, right? And for example, one of the questions would be, and that's also something that irritated me at the beginning. So, is cloud native really something where I need to build my applications based on a microservices architecture with all the complexity that is in there? If I have an existing application that I want to make cloud native and which is monolithic, do I need to split it up in microservices and have all this this additional effort that I need to take? And my take on this is simply no, of course not. So building an application, a new one, or migrating an application, an existing application to microservices, building a new one on top of microservice architecture, or migrating an existing one to microservices, oftentimes is not necessary. I know that many people are talking about this, and they have the idea that they need to use microservices, but in the end, you should have a look at the requirements that you have, how much load your application is expected to get and stuff like that, and then make a good decision whether you actually need to have microservices. And I would say more often than not, you might come to the conclusion that microservices are not really needed, right? Not everyone has the scale that Netflix has or Amazon has, and all the other big players out there. Another question would be, in order to be cloud native, does it mean that I need to use a public cloud like AWS and Azure and Google Cloud? And I would say no, that's really not necessary. You can build a cloud native application based on some of the principles that we've seen before, like you are using containers, you will use lots of automation, and do it on top of a private cloud environment, where, for example, the baseline would be Kubernetes running on some shared resources, and maybe even sharing these resources with other applications, so that the different usage patterns for these applications lead to a better utilization of the resources underneath. And even in this case, if you are on this foundation, it should be pretty easy to migrate the application to a public cloud environment if you want to, or if you need to, or if you should to later on. Yeah, when you do this, when you use this basis, you should be already pretty in a pretty good shape cloud native wise. Another thing then is, okay, and I was also somehow irritated about that in the beginning. So does cloud native mean that you use something like serverless or function as a service? So my first reaction to cloud native was, okay, I built a cloud native application if it can really only run in the cloud, and watch what maybe ties me better into the cloud as running Lambda functions, or building up my application based on Lambda functions. But of course, this is not the case and should not be the case. So that you need to use these kinds of services. They are really nice to use, and they provide lots of benefits, and it's really fun to work with these. But it's not necessary to build your applications with Lambda or Google Cloud Functions or stuff like that. What makes sense is, again, in the picture of using managed services, to use managed services that are also serverless. So where the cloud provider does the heavy lifting for the underlying infrastructure. Like Azure provides something like container instances, where you just say, okay, I want to run my container and I want to run X instances of this container, but I don't want to bother with the underlying infrastructure I need to have, right? Just run this container and stuff like that. Or serverless things like API gateways, or certain database services and stuff like that. There, it makes sense if you are in the public cloud environment to actually use this. Speaking about databases and cloud, the cloud providers famously provide lots of options when it comes to databases. And is it now necessary, when I speak about cloud native applications that should be good, scalable, and stuff like that, that I need to get rid of my SQL database and switch to something like NoSQL? And of course, this is also not true, right? If you are in the cloud, it might make sense to choose your database engine or technology a little bit more carefully. But of course, there is no need to switch to or migrate from your SQL database to something else if using SQL in the scenarios that you are dealing with actually makes sense, of course. And then maybe the last question is, do I need to log me into a cloud vendor? That's always a discussion that we of course also have with our clients, and where still some people are hesitant when moving to the cloud. Does it mean that I need to that I cannot migrate back from the cloud vendor? And here, as architects, we need to make decisions how far we want to leverage services in the cloud. As a baseline, we can, in my opinion, always use something like Kubernetes, where we run our application on, and maybe we use managed services for running Kubernetes instead of doing it on our own, and also leveraging managed services for our databases and storage and stuff like that. But with this, on this baseline, we still have a pretty good option to migrate from one cloud vendor like AWS to something like Google or to Azure or something like that. And I would also add that in the past, we oftentimes discussed about this kind of login with database vendors. So that we build our application, our persistence layer, we try to build it independent of the database vendor or the database engine underneath, with the argument that, yeah, then we are free to migrate our database from Oracle to MySQL, or from MySQL to Postgres or whatever. But in reality, that happened not that often, to be honest. And I think that might also be the case with using services provided by cloud vendors. Okay, so now let's talk a little bit about what is the case if you have an existing application, or you want to build a new application and you want to do it in a cloud native way. And based on the principles that we've seen before, I would say that you can do this in multiple steps. So let's assume that you have an existing application that you want to migrate to the cloud, and that you also want to modernize to be cloud native, or become cloud native, at least over a certain period of time. Or you build a completely new application and you want to do it in a way that you can start, that you leverage cloud services as much as possible in the beginning. In both cases, I would say I would more or less start with the containerization part. So in my opinion, it almost ever makes case to package your application, whether it's a Java application, Node.js, Rails, PHP, whatever, to package it as a Docker container, and use the Docker container as a deployment artifact that you put into your different stages and ultimately into production. And where you should focus on, for example, if you migrate an existing application, let's say a Java application, to the cloud, and you are not running containers yet and you want to do it, you should always look for optimizing the container image and the container startup time, so that you are able to quickly spin up new instances of this application as you need, especially if it's, or maybe especially if it's a monolithic application, which is bigger compared to microservices, which might, of course, start quicker in production. And one thing that you should really take into account, and maybe this is even the case if you are already using Docker, you should aim for getting it configurable from the outside of the container, right? So you should not rely on a different set of properties files inside your application, which have all the different configuration for the different environments, and that are loaded depending on some information that you put into the container, or something like that. So one thing that makes sense, in my opinion, is to configure the containers when you start them with environment variables, and use these environment variables, for example, to configure your database connection or things like that. Another thing that makes sense in the next step, if you are not already doing it, is to automate your build process, right? And maybe it sounds a little bit surprising to see build automation. I mean, probably most of you are already using things like GitLab and Jenkins and stuff like that to automate your build process. But surprisingly, it's oftentimes the case that this is something which is not maintained that well, I would say, right? For example, yeah, you can build your application. Maybe you can also automatically package it with each push of new code to your repository. But then again, things like checking code quality and looking for code quality or improving the code quality is neglected, or aiming for a high test coverage that's neglected because it takes lots of time to do this. But if you really want to profit or benefit from automation in this part of the process, so in the build phase, you need to invest in this, right? You need to increase your test coverage, automate tests, and not only component tests or unit tests, but maybe also integration tests, security tests, and stuff like that, so that you can really rely on this part of the software development process. And one thing that I also included here is this partial build process for branches and pull requests. That's something that everyone also should do, that whenever you create a new branch, create a pull request, maybe in GitHub or GitLab or whatever tool you are using, it makes sense to already run at least a part of the build process in the context of this branch, so that as a developer, you already know if the code changes you introduce break any existing test cases or something like that. And this makes it impossible to for example, merge this branch into the master branch. With tools like GitHub and GitLab, you have these things like protected branches where you can configure this, and this helps tremendously, in my opinion. Once you've done this, you should focus on the automation of the deployment. And I explicitly made a distinction here, because I think having the build automated, that's one thing, but having a deployment, so the actual deployment to whatever environment that you have automated can be a completely different beast. In cloud environments, especially in public cloud environments, this is maybe easier to use with the services that cloud providers provide. But you need to invest some time in doing this automation of deployments, right? In aiming for zero downtime deployments, so that whenever you make a change in production, that this does not mean that your users cannot use the application at that moment in time. That's actually something I'm always somehow annoyed with when every other weekend I cannot use my online banking because I get the message in my mobile app, in the banking app, that they are now doing some service or maintenance stuff, right? And I don't like to see this, and this should be, or we should aim for improving on that. When you do the deployment, you can again automatically check whether the deployments have been successful. You might run to one smoke test against the newly deployed services applications. So try to leverage this, because if you do, and if you have all this process automated, and you know that you can rely on this, this really gives you a good feeling whenever you make changes, and this brings you in the position where you can basically make changes whenever you like, because you know that the stuff is working. when you bring in an existing application or build a new application, you will probably from the first day use managed services like databases. That really makes sense to do this from the start instead of setting up your own MySQL database and administrating your own MySQL database or anything like that. But later on in the life cycle of your application, you might want to leverage additional managed services that are provided by the cloud providers. Maybe you want to leverage API gateways to shield your application from the outside world and use the capabilities of the API gateways they provide, or messaging tools. Like in AWS, you have SNS or SQS for publish subscribe messaging, or queue-based messaging, stuff like that. And this, of course, also lowers your operational effort that you had. It might improve actually the securities that you have. For example, with this API gateway case, oftentimes cloud providers help or include some kind of hardening against DDoS attacks and stuff like that. One thing that was mentioned in I think it was the Google characteristic, is this that you think about your state. So your state management, you should, maybe with existing applications that comes a little bit later, with new applications that comes a little bit sooner in the application development lifecycle. At some point in time, you need to think about state management if you are still storing the state on the instance of the application, right? Because in this case, when the instance is gone, the user session is gone, and this, in the worst case, leads to the fact that the user needs to restart a certain process again, or some stuff like that. So getting the state management right helps you with scalability and resilience. Thinking about how you deal with scheduled events and jobs. So in the end, what you want to get is that you can run your application on multiple instances to have redundancy and resilience against outages that you might have, right? Or where you can really have zero downtime deployments because you can just create additional instances of your application as needed. But with existing applications, and maybe also with new applications, you might have some automated time-based triggers or something like that in your application, where at certain times some import or export jobs are done, or some other cleanup tasks or something like that. And if you are now used to run your application only as a single instance, this is easy. But when you want to run the same application with multiple instances, this of course becomes harder. You also need to think about these resiliency patterns, when you talk to external systems, and this is especially important if you are working or thinking that you need to have a microservice architecture and you are building a microservice architecture-based application. You always need to think about what happens if downstream the application is not available. And I cannot call it. What happens with my business process in my microservice or my part of the application? How do I deal with this? And there are lots of these patterns out there, and you should get familiar with these and incorporate these as needed into your applications to get more resilient, so that the application itself runs better in these dynamic environments that the cloud provides. And last but not least, you should think about decoupling, and this has something to do with the resilience part. So maybe you want to build it as microservices. Maybe you want to break up your monolithic application into microservices. Maybe you want to include new features in additional microservices instead of building it into your monolithic application, stuff like that. You would probably use asynchronous communication as much as possible and stuff like that. And below everything, when you work with cloud environments, or at least with public cloud environments, use as much infrastructure and configuration as code as possible and integrate it into your development life cycle, so that you can actually rely on the auto, or leverage the whole automation part. So yeah, that's a little bit about how you make your application cloud native. And then maybe as the last part, why is this relevant now, right? And maybe, or my opinion on this is, really all the stuff that we talked about in the past few minutes, that's not really something new, right? When we talk about continuous delivery, there was a book from Jess Humble already released in 2010, where he basically laid the foundation or described everything that there is about continuous delivery, right? So this is already known in the industry for quite a while. Some of the things that we discussed before are part of the of what the 12-factor app proposes. Like using environment variables for configuring your application and stuff like that. And this is back in 2011. I think at least that was the date that I could find out when the 12-factor app was introduced. And Docker is also something not really new, where we say a cloud native application is an application which runs containers and stuff like that. It has been introduced around 2013 with orchestration frameworks like Kubernetes and Mesosphere, etc., introduced, I think, in 2014-15. And the basic concept goes way back, I think, to the 2000s, where Google actually had similar systems in place internally and used these things. So this is not really something new. Yeah, maybe the tools are now in a state that it makes it possible for most of us to leverage this. And maybe if we go to the cloud, we actually should do it. Whereas in the traditional data center world, we were not forced to do it that much. And I want to close with two additional quotes in this regard. So one, which is also pretty old, from 2011, or also 9 years old. Marc Andreessen famously quoted that software is eating the world. And I think this is really apparent nowadays. With all the digital disruption that's happening across industries, whether it's cars and software in cars, whether it's services like streaming, and no one nowadays rents any movies, DVDs anymore. Services like Uber, etc. These are all technology companies, and also Amazon itself famously quotes that it's a technology company who happens to do retail. But ingrained in their DNA is technology and software. And the last one comes back to our current situation, more or less. So this quote is, I think, from an analyst statement from Microsoft in April of this year, where Satya Nadella, the CEO of Microsoft, states that in the time frame March and April this year, they've seen 2 years worth of digital transformation in only 2 months. And of course, this was because of the pandemic that we are seeing all over the world, where suddenly every one of us needed to work from home. All the companies needed to switch to remote work and stuff like that. And I think, or I believe, that we will not go back to a world where we do all our work in offices, maybe for Accenture, where we will do all our work at client sites as we used to do, but where we are more flexible in where we work. But this needs to be enabled by the software that's supporting the business processes, etc. So with this, I am done with my talk. Thank you for your attention. And maybe Stefan, now we have time for a bit of question and answer.
Yes, we still have time. Thank you, Jens. Was very interesting. So, and this is also what the topmosted Q&A says. It's interesting talk. Thanks. So this is something nice.
Thank you very much.
And then we have Anonymous with, what are some arguments I can use to convince my boss to bring our apps into the cloud?
Yeah, that's a broad question, and of course a very interesting and relevant one. One thing that is oftentimes a driver.
Before you start, you will not believe there is a whole conversation going on this topic with others writing back and forth. But I will keep that for the end. So this is.
Yeah, I can assume that. So when I talk to clients and about cloud and cloud migration, one of the things that often seems to be the main driver behind cloud migration or bringing your applications into the cloud is cost savings. In my opinion, you need to be very careful about estimating any savings and cost, any cost reduction that you can gain when you move to the cloud. For me, the main driver should be that you can get more innovative, that you can get faster and more innovative. And I mentioned this in the talk. So one of the things that you can do when you go to the cloud is automate lots of stuff, whether it's for deploying your software, but also for operating your software. Lots of the stuff can happen completely automatically, and you can use the time that you needed to invest previously for this to build actual features, right? To free up the time for your developers to build features relevant for the business, for the core business. And then the second thing is, when you are in the cloud and when you are in the cloud and you have you feel at home, so to say, you will begin to use additional services. So these managed services that I mentioned before, where suddenly it might make sense, or you might want to experiment with some services that help you with recommendations, with giving recommendations to your users, with automating some processes, with bringing in AI or ML or something like that, to improve your processes and maybe to reduce the time that your users are doing manual things or something like that. And if you are in the cloud and are used to this, then it's more likely that you will just try to experiment with these services when they are released by the cloud vendors, and can come to new ideas how you can improve your application. So innovation should be the main driver. Cost might be something where you could also gain some benefits. But for me, innovation should be the topic that you should discuss.
Yeah, okay. So now I give you what the crowd found as a solution for the cloud. Is Statis wrote to Anonymous, search for monolithic versus microservices. And then like 3 minutes elapsed, and then Anonymous wrote back to Statis, thanks, but the technical aspects are not the issue. It's more money, security, and so on. And then Statis came back again and gave something which is a very nice answer, which also resembles, I think, a lot of the experience we all made at some point in our career. It seems that a small founding team with small projects is better suited with monolithic, but larger teams with huge apps benefit from microservices in the long term. And I think you start everything as a monolithic thing, and then you break it apart because it gets too big.
Yeah, that's actually a very good observation, and I can very much relate to this. So thanks for sharing. Yeah, makes sense.
Yeah, and believe it or not, but the whole conversation on this question was it ate up all of the question. But I have one question I ask myself, just because of the topic of this the topic of this talk, and you had in your slides the term vendor login, And when I came in first contact with cloud thing, there were a lot of people preaching, yeah, let's do cloud agnostic development. Does this still exist as a term, or is it just that, yeah, you only put as much logic into the cloud as you need to in one place and separate stuff?
Yeah. So yes, the term of course still exists, cloud agnostic. You want to, or many things start out with they want to stay cloud agnostic, or they want to be cloud agnostic. There are tools out there that helps them with this, more like from a tool chain perspective. For example, Terraform is a tool which helps you script your infrastructure. I think they still say that they are cloud agnostic, more from a workflow pattern, because the templates that you are actually building. So I personally, I do not know a tool where I can set up an infrastructure, maybe a classic infrastructure with network, load balancer, virtual servers, databases, maybe some content delivery network and all the security stuff around that, where I can do this in a cloud agnostic way, where I can say, okay, I have this template, my infrastructure coded, and I can apply it to Azure, I can apply it to Google, I can apply it to AWS. I am simply not aware of any tool, and this is very hard to do, in my opinion. But what you can do if you want to be cloud agnostic, and I briefly mentioned this in my talk, you can have from a technology perspective some kind of baseline. And one of the baselines that we often see is that clients or that teams say Kubernetes is their abstraction layer, right? They introduce Kubernetes, and on top of Kubernetes, they run their services, their applications, stuff like that. And this makes sense somewhat, because Kubernetes can basically set up everywhere. So every cloud vendor has some managed offering for running Kubernetes, where in the end, you just need to put your containers in there. You can also build this up in your own data center. And if you only have virtual servers somewhere at some hoster, you could basically also set up Kubernetes. And with this, you have some kind of abstraction from the cloud infrastructure. But in the end, you are somewhat limited about what you do with the cloud, right? As soon as you start to leverage managed services that the cloud providers provide, you are somehow locked in, right? Although I would not stress the term too much, or you will simply run all your infrastructure or supporting services on Kubernetes and are responsible for managing it, patching it, and stuff like that, and then you do not really gain much in this regard. I hope I was able to answer the question at least a little bit.
No, you were answering that question quite good. Thank you, Jens. There is one last question. It's actually a strange question. A colleague of mine wrote me a message before and wanted to know what stands behind you on this wall you use as a backdrop. It says "Together greater than ever." Okay.
Yeah. So that's an Accenture. How do you say? Quote or mantra?
Mantra. Okay. Okay. So. Thank you for your talk and for your time, and also for the insights you gave us. And I will now, for you audience, roll the loop and make sure that Jens finds the way from the stage. So loop is rolling. So, it's me again, and I am already excited because our next talk is already waiting on the stage. This is about function triggers using Azure Event Grids. Oh, look at this. I need to fix this in my own programming using Azure Event Grids in Azure's Blob Storage. So for all of you fans out there of binary objects, this talk is for you and of course for me. Okay, see you soon. Oh my God. So, hi Menaka, stage is all yours now. Hi.
If you see today, the topic we are going to discuss is completely about somewhat related to storage and somewhat related to serverless. So if we go with the storage, it's somewhat depth. Same if you go with the compute things like functions, serverless, everything, it is also a little in-depth concept. So covering both the depth concept, we have one common platform. It's my main goal today. So we don't need to have a lot of knowledge before to start working in serverless or even with the storage things. Because why I'm saying like we don't need to have a lot of experience or a lot of backgrounds to start working in both the services of Azure is compared to other services where we need to implement some of the features, we need some background work which is already done by us. If it comes to serverless, we can implement everything either via the portal or via PowerShell or CLI, anything that in which we are capable of. Same thing is applicable to blob storage. But if you are implementing anything, either it's a Cosmo DB or any other services which related to storage, we need at least a maximum knowledge of working in a database side. So that's what working on serverless as well as on the storage in this very beautiful compared to other services, which is this is one of the best service I like most. That's what I took a combined thing of a function with a storage, not completely going with the serverless concept and not completely going with the storage concept. We are going to see some real-time application, how we are going to use these strategies when we are developing something, where we can reuse our things, where we can reduce our manual efforts. Those kind of progress we can see in today's discussion. Let me introduce myself. I'm Menaka Bhaskar Pillai. I'm working as an associate software engineer at Accenture. I'm an Azure and .NET certified professional. Spend my valuable time in tech blogs, and I'm a Shisha Corner most valuable professional. This is my platform via which you can contact me for any doubts. So let me go to today's agenda. If you see, I shortlisted some of the things which I'm going to discuss in my presentation, and some of them I'm going to discuss in my demo. So I cannot explain completely about creating blob storage and how to work with blob storage, other things. At most at end, I try to cover the code end as well as the working of function end. Other topic like functions creation and event grid creation, I will discuss in up to max with oral along with some of the demo. So before getting into agenda, I have one requirement, one serious requirement in my project, in which I want to, it is an attendance application. This is an example where I want to use Azure AI service to capture my face as a facial recognition. That face need to be compared with the faces that already existing in my blob, and it need to mark the attendance. This is my first case scenario where I need to create in a first phase. So once after my face is detected and it is verified by using cognitive service or any other Azure service, at second, I need all the processed images to be in a downloadable version that I can easily download that images in my device. So what is the use of downloading version? Maybe in different cases we can use, like to track the attendance for people photos, and I can use it as a model to train my future forecast also. So all those things are very needed. So this is my in-demand scenario. So what kind of activity I can do in this situation? If you go with a normal activity, creating a model, training a model by cognitive service, that is somewhat in a machine learning, and even we can do the thing via our normal cognitive service by implementing face recognition API. But if we are coming with this second half, we definitely need something like a Azure function or any event grid to process the photo in a mobile friendly version, because every time a user or a people who be entering into the attendance room, photos need to be downloaded. It is a routine process. So wherever we have the routine process, wherever we have the process that need to be repeated, we need to go with function. It is nothing but like a web jobs. So in higher end, we will have a timer or synchronization. So in that case, we will go with a durable function. That is somewhat in depth of Azure function. In a normal scenario, as I told, like tracking the attendance and downloadable version, it is a common scenario where I don't need to implement lot of things, but I need to do something with function. So in that case, I can go with Azure function by using event grids. I can easily able to download the mobile friendly version of my picture, and that I can use for further processing. So these kind of activity never require a lot of manpower or developerian work. If we have the knowledge of Azure function, we can easily do the second phase in very less span of time. Anyway, if we have a knowledge on a cognitive service, it is very easy for us to work on the first phase also. So if you know the process of how to use the service, that makes us to reduce our work, what we are doing with the regular strategy. That is the beauty of working with cloud services. So let's come to today's scenario. Why I explain the requirement and the need is, when we are learning one service, we need to know where we can apply. So if we go and read something in any services, we don't know where to use that, and there is something that is need to be taken into count. So whenever we are getting into any services, the implementation is must that need to be considered. So that's what the function and event grid is doing in real-time scenarios. We can see that in detail. So today's agenda is about event grids, functions in the point of serverless concept. It's obviously blob storage, and what are the types of blob storage, when we need blob storage, ways to move data to Azure Blob Storage from .NET Core. If you see here, I am covering a blob storage as a demo purpose. Since as I told, I am using attendance application, my photos. So obviously for saving the files, I can go with the blob storage of Azure Storage. See, the same process we can able to do in the Cosmos DB also. The steps are similar. Since it is my requirement is based on photo processing, I'm going with the blob storage. So other last thing here we need to see is .NET Core and blob storage. Even nowadays we are not using a .NET framework, but yeah, existing application are in .NET framework. Nowadays we are migrating to .NET Core, and we all know the reason, because of its compatibility, stability, reliability. So that's why creating something and as a demo in a .NET Core is useful for everyone. That's why I created a blob storage demo in .NET Core. Other than that, we are going to we are going to see some of the futures of the blob storage, because that is very necessary whenever we are going to save files or whenever we are going to process the files in blob storage. Without knowing how the place we are storing the file, and we cannot do the other action accompanied with that. So that's what we are going to see in today's session. So yes, this is the view how exactly event grid works on. So we can have any kind of event source. As I mentioned before, we can have a Azure Blob Storage or a resource group or any of the services as our event source. So what we are doing, the Azure Event Grid, it is acting as a moderator, as a center plane that acts as in between the event source and the event handler. So if we are using a blob storage as an event source, as we are going to see in our demo, we can have a event grid combined with the event handler, either it's a function or any other things like workflow integration or other application services. So what's the beauty of this event source and event handler when it comes to event concepts of Azure is we may look into many of the services where we are having the service that being accompanied with other services. If we this is one of the key point, the service that is accompanied with other services. The Azure have many of the services inbuilt, it is accompanied with other services. If we are going with the function, we have something called events, so we can exactly we can do the process from the function end itself without navigating to the event grid. So before going into separate event grid topic subscription, we have the connection path that will existed between the two services that make it as to work in ease of other services. So if we go with the blob or any event hubs, as well as the even if we are going with the IoT hub also, we have the some way being connected to the handlers or any other services or application by means of the EC path. So that's the thing why connecting the services of one to another is very easy if you are going with the cloud. So the second thing about this event grid is, why not other, why we need to go with event grid? The most, as I told before, the connection or the interlinking between two things are very common here. So whenever we are going with other services, we need to do some other things before getting into. But if you are going with the grid, it's very easy to connect after you are creating your services in function and running and testing your sample code. Once again, you don't need to navigate to some other place. Once again, you come back to your events where you can able to create by means of single button click, and you can able to create other further things by means of function itself. So that's the service interlinks make it ease of use Azure Event Grids other than other services. If it comes to event handlers, probably event handlers are one of the main thing. What we are going to do is completely depend on the event handler. Even we can able to use other services as an incorporation between the two, but handlers plays a vital role. So we can use event handlers as a logic apps also. For example, if I want to create an application that need to specify the, for example, it's a time where we need to track the details of some post that being posted in a social media. I just want to filter that particular text, whether it is a good or bad, based on the text analytics API, and then I want to trigger some message to the admin team, as well as I need to block that. So further actions, like whenever we are going with the messaging actions also, it's like a repetitive task where it need to done on a cycle. So in that cases, we can go with the logic apps, as well as we have event hubs and storage queues. Queues plays an important role as before. This today's implementation is based on an attendance application. That's what I'm going with the blob storage. In some cases, I will have a project where I need to where I have a microservice project. The update of one table need to be analyzed by the next table, and it should be done by means of logic app and queue. So in that case, probably I need to use a queue where the where messaging event plays an important role. The other thing is like webhooks. If we have no requirements, but I want to learn something about Azure function, instead of going with other things which have some depth which need to have some depth knowledge, I can go with the webhook. So it's very simple to create either via PowerShell or via Portal. So for simple analyzing purpose, we can go with the webhooks. Other than that, what are the things we can use as an event handler? Probably service bus, and it is like as I said, like for microservice, we need a bus service to establish a communication between the two services. In that cases, I can use a service bus. And event hubs, probably we all know, whenever we need some events to be established between two things, we can use that. Probably that is very easy for use compared to other handlers. And most preferably I wish to use like Azure function. Why? Because that's something like when I started working in functions, I haven't gone through before about the serverless things. So at the time, it's nothing seems to be hard for me when it get into the function. So every application, when we are doing something like in a processing manner, in a timely manner, probably if we use the functions, it makes our work very easy. Either it's a function, or we can go with a function app, or we can go with a durable function. Durable function is something, it's a stateful, so we need to have some of the base knowledge that related to functions. So before getting into durable function and higher version, it's very easy for us to work with Azure functions. So that's what I choose Azure function as my event handler, and Azure Blob Storage as a event source of today's demo session. And this is all about the event grid along with the event source and event handlers. So this is a concept how the events being worked on in the Azure Blob Storage, as well as normally how the normal event grid works. So if we have the event, it will be get into the event source. So it's not being directed directly to the grids. Grids have some flows to be taken before it is getting into the other action. So if we go to the topics, when we go with the search bar of Azure and we can check for the Azure event grid topics, then it will definitely ask you the subscription point of view. So you need to create a subscription from the end of the topics where you need to give the function. So you need to already have the function with the event grid, so that you can employ that in your creation of event grid. So once it is done, it can be converted to the event handler. So the flow is directed from the event to event handler. The three boxes in between being done in a single view UI. So you don't need to migrate from one tab to another tab for creating a source, or source need to be created separately, because that is act as a source of the event for topics and subscription. But for using a subscription and topic, you need to have function which has the event grid. So via that only you can create a subscription where you need to give it as a mandatory fee. So other than that, if this is from the function end of point, where I can use the function as an event handler. So if I use with webhooks or another as my event handler, the view may be similar for all, except at the end box, the event handler will ask you something for what you are employing, something like based on your event handler, your subscription things will get changed. For example, if I'm going with the normal function, I may have like my subscription related to my function, or my function event grid something. If I go with webhooks, it will differ. If I go with the logic apps also, it will differ. But make sure the event source and your grid and event handler has ease of use, because if you go with the webhooks or something, it's very easy if you go with a step by step. If we have some other things like logic app or something, we need to have some depth knowledge of both logic app end as well as on the serverless end. So that's about a grid concept, as I mentioned in this screenshot in this. So let's come to Azure function end. If it is a serverless event processing. So already we know serverless is not only employed in backend code, even with Angular and other things also, serverless is being utilized. If we are if we are a normal .NET developer, we will employ that in our backend code via Visual Studio. So if we are on a front-end developers, they will start to employ in your VS Code. So where they can use the functions directly without using the emulator. So there is no need to use emulator or another setup for that. So that is the case where function plays its main role. So Azure function acts as a serverless event handling thing, where you can able to process every events without need of any server. So how it works is, it's my device, it's established some events where it will get into the event hub. Once it is done, it will be employed to the function app. I can have a write on my DB as well as the letter message on my storage queue. So all those activities I can able to do via pipelines. That is like a deployment process I can able to do in my pipeline by means of KIDA. Like that is some concept that is related to the deployment activities like Kubernetes event driven auto scaling. Whenever we need to deploy our function app, we need this service, because if we deploy a normal function app, the auto scaling process will not be happen. The main reason of this issue is like we need to increase the pod or we need to decrease the pod, because we don't need to keep the pods count same. Sometimes my application will remain idle. In some other case, my application will get lot of requests. So balance the request and to make my application available all the time, I need some auto scaling process to be done. I don't need to pay extra for what people not using. I don't need to pay very high for the application which is idle, where there is no use, and where there is the number of customer usage is very less. In that case, autoscale plays a main role, and this is related to the VM concept. The same thing was applicable. In that case, I need a KIDA service that need to be employed whenever I am deploying my Azure function app. That is on the deployment end. If we come to the monitor end, like normally if we have any application, whenever we are creating and publishing in Azure, we will go with the application insights. In some cases, I need to go with the Azure monitor to monitor the health of my application. So now after the build 2020, the monitor service been interlinked with the analytics, log analytics service. So that is very useful nowadays. So I can able to view the number of requests to my server and number of processing, everything happened by means of simple query that I can able to write on the portal itself. I don't need to have any on-premise environment to run that query. As like Kudu service, we can able to do this in our portal itself. So monitoring end also, processing, whenever the things are getting processed, we need monitoring end for the functions also. It can be done as a normal thing. We don't need to set up separate thing as like a KIDA service for support a serverless event. So what is about write and dead letter message? Every time whenever some processes happen, there is for sure there will have a log file to be generated or something to be written somewhere that the event is processed, or that the failure messages or anything. I usually need a block file to be generated that need to be stored somewhere. Even for blocks, after reading a particular blob, I need something to be triggered on my backend, so I can able to monitor either the process is happening correct or not, either the process has some failure rate. Normally the web jobs will have a collection of logs. Based on the logs collection only, we can identify either the particular server is running on night or not. So the same process we need somewhere to be stored, so that they will have some write option to be there available, along with the dead letter messages also that we can done in storage queue, where we can use this write letters in our Cosmos DB. So this is about a function. So I thought like I started covering from events to deployment end in functions. So let's go to next. So Azure function as an event handler for grid events. So what is the use of event grid with Azure function? Why it is like, what is the reason for the scenario? As I mentioned, my project requirement to download the mobile friendly version of the particular images. If you see, in that case, I need to go with the thing that make my work easy. That's what I told, like event handler and the choosing the central component like a grid is very important. Whenever sources, we cannot say like I can choose the source, because the sources which we already have, so we don't have an option to choose the source. Either we have a blob or IoT, we can able to choose the handler. So in that end, I can able to choose either webhooks or logic apps or function based on the things that is already available. If I am go with the requirement, I have to process the images and I need to make it as a downloadable and friendly version. So the resizing of the thing, because someone will download on the laptop, some others will download on mobile. So to make it the size available in all shape to all people, I need to go with the resizing. So it may, using the event grid with event function, make it ease of resizing the uploaded images. So this is the main reason why I am choosing the event grid. So the requirement is to resize. So the resize, I don't need to do some other things after downloading. I don't need to add some other programs or code to resize it automatically. So if I employ my event grid, it automatically resize my image. I don't need to worry a lot about the second phase. So other thing is stream big data into data warehouse. For example, Snowflake. For whenever we are going with a data warehousing technology, we will have a Snowflake, the most commonly used tool. So in that cases, streaming of big data is very difficult because .csv file or any other file, whenever we use certain file to stream as data streaming part, it's very difficult. In that case, whenever we are using a grid, make it easy to maintain the flow of data, a stream of data into the data warehouse. So employing the grid and function plays this much efficiency in my current requirement, and that's the reason I'm going with my event handler as a function. So this is a main concept, and this is a main reason why we need to employ two services, because the two services are somewhat linked to each other, and connecting the two services also easy without migrating between two other things. And this have the future that supports my current requirement, and that is a basic thing which I am choosing my grid as well as the function. So, and we are coming to other part like storage end. Why Azure Blob Storage? Why not Cosmos DB? Why not other? If we are going with Cosmos DB, we have several APIs. Cassandra API there, MongoDB there, SQL there. So Cosmos DB looks good. Why we have lot of other API supported and other features also there. It have very good throughput consistencies. And why we are going with a blob storage as an example rather than Cosmos DB? Other than that project requirement, we will have some other things to discuss. But why I choose the blob storage then Cosmos DB is, if I see Cosmos DB, the usage of Cosmos DB, whenever we are developing an enterprise-based application, is very less compared to that of blob storage. Why? Because it's somewhat cost effectiveness is little bit higher. The cost effectiveness is little bit lower. Sorry, we need to pay little more for Cosmos DB because it's based on the throughput. So the write and read operation depends on, they make it as a little bit costly. So whenever we are employing Cosmos DB in our application, we mostly use the Cosmos DB in migration part. Why I am saying is the application is already written in a SQL query. I need to migrate. Probably it's somewhat difficult thing because migrating the something which is written in something to something which I don't have an idea is somewhat difficult. In that case, Cosmos DB have a separate thing API that supports the SQL query. Same thing applicable to MongoDB, same thing applicable to tables, and same thing applicable to SQL. So existing application migration where we don't know the particular case, how it will get affected, or we need to do a lot of recoding or rewriting, things will be decreased whenever we go with the migration end. If I already have an application that works on SQL, migrating to Cosmos DB by choosing the SQL query as an API, this makes me to work efficiently, and it will reduce the time consumption which I already have the knowledge of SQL. So I don't need to bother a lot about the migration thing. In case I have no idea about schema, I want to do something, we can go easily with SQL, where we don't need to worry a lot about the existing things. We can start working in any sort of environment. So in that cases where we need to choose the other things like consistency model, either it's a strong, eventual, Based on the consistency model, we will work on Cosmos DB. So if it is a normal application, we will need to do some of the new processing or new things to be added. As a storage environment, choosing a Cosmos DB is very lesser. But if you come to blob storage, today's, as I told, today's requirement also, it's a processing of the photo. Probably file storage, where we have Azure Blob Storage, which is very good to use, and its efficiency also very good, because it usually when I have an application where it have to process some pictures or it need to upload some pictures, it will take some time to replicate its changes what we are doing in DB. For example, if I have my pictures in somewhere in my DB, whenever a user upload, after he need to wait some time, and he need to do refresh again and again to check whether the process is loaded or the photos are loaded or it's downloaded. In that cases, it makes us to work efficiently. With a single click, all my photos will uploaded with no time elapse. So the processing speed is very high. So it is used for storing and accessing the unstructured data at scale. So I can able to store my data, that is my unstructured data, at any scale. And it's a built powerful cloud native application. So whenever we are going to work with a cloud native application where we need to use pictures or unstructured file data to be stored, we can employ this blob storage. It supports it. It's a good to use service. It's something like a cool service. I can say like a cool service. We can use it like without having a lot of knowledge like Cosmos DB, because Cosmos DB we need to have something like what type of query, what type of things, schemas, and everything need to be considered, throughputs, consistency. So those kind of things we don't need to. By creating the service, we can easily able to work on this service, and it's a storage of petabytes of data. It's a cost effective. So even we have pay-as-go service also, the cost effectiveness is very good in blob storage. It's a powerful data lakes. So this is also another important point, that it is act as a powerful data lakes. So how this blob storage resources will be there? So if I have, we will have a box where we need to store something about videos and images and some other things. If I put everything in a single box, it's very hard for me when I am retrieving. So if I create a separate folders as I'm doing in my personal desktop or my document section, and I will put it as an image, videos, and then I will store that a particular file within the particular division, it makes me to ease of work. So in that case, we have an account of storage, that is a storage account in a particular name as a demo. After that, I'm going to create a separate container for the separate files. Example, either it is an JPEG file, I can create a separate container. If it is an MP3 file, I can create MP4 file. I can create a separate container. And if I put everything inside a particular container of based on his destination, it's very easy for me to use rather than putting everything inside a single container. And that's where the blob storage works efficiently. So everything can be categorized as a container, and based on the container, we can be able to store our files. So types of blobs, like this is like something important when we are getting completely into blob. So we need to know about the blob append and page, because we will use terms like blob and append blob. So those kind of words plays a vital role whenever we are writing the code, whenever we need to store things via our code, that is .NET environment. If we are going with our normal portal environment also, we need to know these terms, because some cases we need to overwrite some. In some cases, we need to optimize things based on things. So I need to differentiate between the blob and append, so that makes my work's efficiency to bit higher. So what is blob is, it stores the text and binary data are made up of the blocks of data that can be managed individually. So normally if we have a building, the block is something which have the particular data that been managed individually. So append is like it's a blocks. It's a complete, it is made up of a blocks like a blocks, but are optimized for appending operation. Usually append means we are just going to add something and we are going to do some activity based on that. Pages, it is if we store a virtual hard drive file and serve as a disk for Azure virtual machine. So pages sometimes this kind of Azure virtual machines will be a separate concept like a VM concept. So where we need to employ our disk size and separate things that need to be do. For example, I need to have download the RDB file where I need to do some operations in VM. In that cases, files are very important. So in that cases, we can use this block page. So these all are the types that are available in blobs. So where we need to use blob storage, today's requirement is one case where we can use the blob storage. The other requirement is if I have some documents, if I have some invoices that to be processed. For example, we have a new service like form recognizer service. Let's take that as an example. I want to extract the invoice number and tax number from that form. If I go with the regular thing, I need to do some automation work to do that. I need to employ some RPA work to extract the information. I don't need to worry a lot about that things because the form recognizer itself extract the text from the form. From that means I can able to process. But to process this activity, I need that file to be available easily in my cloud. In that case, I can able to use the blob storage. This is second requirement where I can able to use the blob storage. Another thing where I can able to use the blob storage is sometimes I need to read some data or something from the uploaded file. So after uploading, I just need to read some words or I just need to get some things from that particular file. In that case, for example, the real-time example is like I have the document that to be submitted to my higher team, where the team need to process the document and they need to extract the information from the document and they need to give that data extracted to some other team. So it's a cycle process where the documents reading and extracting the data will be get transferred from one team to another team. In that requirement, I probably need somewhere my files to be stored. The application runs will extract the data and print to me, so I can able to forward that to my next team. So it's a daily activity, so I don't need to send a file again from that file someone they need to read my file and then again to next team. So in that case I can able to use the blob storage. So serving images or document directly to a browser. Yeah, this is a demo today we are going to see. And storing files for the distributed access. This is what I told, like distributed access. The same file need to be go for a routine work from one to another. And streaming of video and audio. For example, I'm opening a shop for selling my coffee shop where I need to sell my coffees and some other things where people need to view as a video and listen something as an audio. I can use that blob storage where I can give to my admin end to upload the videos of my coffee shop, and that admin will upload the video from my normal application, and the viewers can view that video at the other end. So in that case, I can able to use the blob storage for uploading or hearing anything based on the MP3 or MP4 format. So writing to log file. This is very important. Whenever an jobs or something running, I need to get a log files. That cases I can able to store that in my blob. Storing data for backup, restore, disaster recovery, archiving. Whenever we are doing any deletion activity, we need somewhere the data to be stored for prevention purpose. In that case also we can employ this blob storage. Storing data for analysis by on-premise or Azure hosted services, and we need to store some data that is like an activity to be done. For example, I want to do a weather forecasting application where I need to store every month data so I can able to train my model. So in that case, for 6 months data I want to store, I cannot go with the Cosmos DB or some other storage. I can go with the Azure Blob Storage as a storage event. So this is the place where we can use the blob storage. So how costing works? If it comes to blob storage, the volume of data stored per month, the cost. Every services have the costing based on the different ways. For example, as I said before, Azure Cosmos DB based on the throughput. So the read-write operation defines its cost. So if it comes to the VM, the running cost, the time it runs. So every service have its own subjects where it will determine its cost. If it comes to blob, how much amount of file we save in our cloud, that makes us to pay that much amount. So the quantity high, the amount will be high. The quantity and type of operation performed along with any data transfer cost. For example, only storing file, I can able to store a lot of files. Based on that cost, billing will be done. In some cases, from that file, we are performing some other actions. As like I mentioned, like event grids or a mobile friendly version or any other action, like I'm generating some other logs based on that action. So in that case, the costing will be high. So data redundancy option selected. This is main thing. Whenever we are creating, the hot and cool tiers will be there. We can able to choose the redundancy based on the type, whether we will go with the Cosmos DB, we will have hot zones and cool zones. So similarly, we have some data redundancy options being selected here, so that establish our costing also. So this is how the costing works. So ways to move data to our blob storage. It depends on the volume of data stored per. Okay, I think it's a repeated slide. Oh my God. Okay. How to choose pricing plan. So whenever we wish to choose the pricing plan, I told already, like it's a Cosmos DB or a blob, we can choose a hot, cool, and this is a data redundancy option that determines our cost. So if it is a premium, it's performance sensitive data. Whenever I want to store the client secret credential in my storage, that need to be, it's a very sensitive data. So I can be able to go with the premium plans. So if it is hot and cool, the frequency of accessible. So if the application is used by regularly by more number of users, I can go with hot tier. If it is go with the less number of users, I can go with cool service. And very rare for a monthly once or monthly twice, I can go with archive plan. If you see, mostly the as all of us think, the hot plan will cost more because the frequency of accessing data is more. So no, the cool plans will take more cost because the data being stored and being preserved somewhere for long without accessing. So that purpose, the cool plans will cost a little bit more than hot plans. So why not other cloud service? Why with Azure? And we already know, like a data security, they invested nearly $1 billion USD annually for data security with 3,500 security experts and more certificate of compliance. And that's the reason of Azure as a cloud service here of doing and processing data of clients in a secured manner. We are going with the Azure. And second thing is, like whenever we are working as a .NET based or a .NET developer base, it's quite easy for us to do other activity, publishing or application insight. Telemetry actions can be done very easy from the .NET 10 to Azure. The navigation and deployment, for example, directly it will connect to my home branch or any branch in my Azure DevOps. Similarly, with my application insight, everything will be easy when we are working as a .NET developer to Azure. That's what .NET and cloud as an Azure are both a born beauty, we will say. So let's go with the demo session. So what I did here is, this is my blob account, that is my storage account, which I already been created one account. So this account I'm not adding uploading files directly. For that purpose, I already created one application based on .NET Core Blob Storage. This is the application. This is an example application. what I'm doing here with my code is like, I just want to upload a file here. So what I'm doing is, I'm uploading any of my file. So I can able to see my file here. So rather uploading from this end, I just created a one .NET Core application for that. Let me show that code at end, time permits. So this file is being uploaded to my Blob account. So I can able to do this easily from here also, but for requirement based, we are doing from here. So if you see the code, that's how it works. Normally, normally we will go with the part, like we will go with the application or JSON, where we need to do the connection string details. If it is a test or development environment, we can go. Otherwise, we need to go with the Azure Key Wallet. And then I'm going to do the other views and models based on the requirements, like if I want to create a delete and downloadable version or something, I can write the code as per its need. So this is where the controller code's been written. So what I did here is I just given the container. You can able to create a container within the blob, that is storage account. That will be created at the first part whenever you creating it, launching it as a new application. Once the container is created, you can able to recheck other time when it is creating or storing some files. It no need to throw an error like container already exists, so go with the container if not exist, and then it will create, and the same thing it will display as usual, like a normal CRUD concept. Like we can able to view it as a list as I shown in my output. You can able to download it, as well as you can able to delete it from this end, and along with the uploading option. So all things can be performed here. So whenever something or when changes are happening here, that is from my application, it's been replicating to my blob. Whenever some changes are replicated to here, I need to get a notification, or I need to receive some jobs to be done. So in the case, I return a function for this, where it will gives me the notification or every option, every process I'm doing in my application end. So this is not a dependent activity that I need to do separately for every time. This is a tracker activity, that is every time what the changes that is happening, whenever either it's a creation of blob or either it's a deletion of blob, every time whatever things I'm doing been recording as a function process. This is the last file I uploaded. Since I written this code only for uploading option, the same thing will be applicable when we are going with the download, creating blob, deleting blob or something. So this action don't need to be done separately whenever we are doing. Either it's from a Azure end or it's from a normal code end. So it will automatically run independent of you need to do again, or again you need to track, or again you need to check whether it is working or not. It will do automatically. So in this concept, it works. So this is a function app that been created, where I given my Azure Web Storage as this. This is a code and a function code where I given the container name, and this code I written only for the uploading that I choose whenever the blobs are created I can, and similarly we can track everything. And if you want to do the same process for HTTP triggers also, we can able to perform that. So the last file I uploaded is like a 12 PNG. It gives me the size along with the name. Similarly I can able to view or read my data also by this process. So this is how the Azure functions works with Azure Blob Storage. I hope I covered maximum. So let me say thanks to all for being to listen my session. Thank you all.
Oops, now you can hear me. Hi.
Yes.
thank you for your presentation. So let's go to the question. So did you try other cloud services too?
Yes, I
Yeah.
tried other services too.
Okay, you don't want to elaborate. You mentioned,
Yes,
I think the question was asked before you told why you chose or why Azure was chosen for this project. So
yes.
yeah. So, and when did you start learning C sharp? This is a question from me.
I've been a Microsoft student partner at my engineering days itself. I'm started working a year before. So from a student of a college, it's been from the track of Microsoft technologies, either it's .NET or any other technology that related to Azure. Now it comes to Power BI, SharePoint also. So it's been a long where we started those things.
Okay. And how did you actually get into coding? This is something which I think interests a lot of people out there.
Of course, actually, I'm from a non-IT engineering background. I'm an electronic student, where we need to write a breadline codes, where we are not going to write in a system codes. We will use microcontrollers and processor. I feel like studying that and working on this is quite easy, rather writing a microcontroller code or a processor code. So that makes me easy to get into actual IT coding.
Yeah, that's true. And do you still do any electronics as a hobby, or electronics is over now?
Electronics is like my passion when I started getting into college. Electronics is my passion of choosing, because every college will have put electronics in the first row, and then after that other engineering groups will be there. In India, it's quite good if you are going with electronics. So that's what I choose electronics as my background.
Okay. So, and what big project is next on your roadmap? What do you want to do next in your life?
Actually, my hobby is to, I wish to share knowledge usually, whatever the thing it is. The hobby is like other than my work, other than these things, I usually wish to do things which makes me satisfied. Sometimes I feel I couldn't be a teacher, so I could teach for 24/7, but I cannot now, so I choose this as a platform.
Yeah. So maybe at some point in the future you will be able to teach other people. Well, you already started by sharing your knowledge about blobs with us. So I say thank you very much for your time and also for your presentation and for staying up late because it's already 10
p.m.
10 p.m. Yeah. So thank you and
Thanks.
have a nice evening. And I will roll the ad and the audience will be able to join after a short break together with Johannes.
Thank you. Thank you, Stephen. Thank you, Visla.
Thank you.
Your app just crashed. It was struck by a hammer manufactured in 2005 by Harry's Hammers. The hammer's head is composed of 75% nickel, 20% steel, and 5% iron. Curiously, a hurricane just came down in Iran.
Hello, people. This is the last talk of the day. And as you can imagine, we saved something which is on our mind all the time when working on code. Because there are two things you can do. You can either work effective or you can work efficient. But how do you remember everything and how does it all come together? Do not listen to my explanations. It's better if you listen to Johannes, because Johannes will be next and he will tell us everything. Well, he said it's a little bit introductory, but for starters, and I think we are mostly starters in architecture decision records, he will tell us most of the stuff we need to get started and head into the topic. So I will not keep you from the stage, so I will take you there and let's meet Johannes. Hi, Johannes.
Hello.
The stage is all
Nice
yours.
to be here.
Yeah, it's cool.
Thanks. Hello to the last talk of WeAreDevelopers Day 3. And this talk is not so much about coding as promised. It's about architecture decision records, a technique we use in our team intensively over the last 2 years and found it very, very valuable. And this is why I'm giving this talk mostly in German. This is the first time I'm giving this talk in English. And as you might hear, I'm German, so don't expect too much jokes and hard pronunciation. And before you ask, this guy on the right on the slide, it's not me. He's looking like me, but it's not me. So little introduction of myself. I'm working at Deutsche Bahn, German railway, big corporate company with a lot of subsidiaries. And as you can see on the bottom side, I'm working for DB Systel. I don't know how to pronounce it. I heard several different pronunciations before, but we are the IT digital partner of Deutsche Bahn and trying to drive the digitalization of Deutsche Bahn. So what are we doing in our team? We have the problem as a product development team that we have a lot of decisions to take, and a lot of decisions in an agile environment where we're working in are wrong or right. So, and we have to document this because we don't want to get into the blame game, which is very often in a corporate environment. So for a little motivation on why to use or why to document decisions, I have a funny little example, I hope so, a funny little example from my last team. And my last team maintained and developed the so-called service portal where you can order, for example, laptops, software, and a lot of other stuff. It was actually a service-oriented architecture, and service-oriented architecture was already, I would say, domain-driven designed, because every service was an own encapsulation of a domain. And there also was a shop, which is signaled by these staples here. And as you might think of a job, there is a traffic light system to show the availability. That's common. Is it available or not? And what you might think, there's a service and this is connected to a logistics system, for example. This is what you think. The logistics system knows how many laptops there are and sets the traffic light in a database, for example. And I stumbled upon the technical documentation, architecture documentation of this service, and found out that it was actually someone who maintained an Excel sheet about availability status, and there was a so-called enterprise architecture integration pattern which merged this Excel sheet into the traffic light status. So I came across and said, yeah, what's that? Looks funny, works perfect. There was never any problem with this service. So there must be some kind of reason why it's implemented this way. And I asked my senior architect at that time, I wasn't long in this team by then, my first few months, and he said, yeah, that's a funny story. This colleague here on the left side, he said, yeah, I know it's dumb to put it in an Excel sheet and to maintain it manually, but it's the way it's always been done and it works. So yeah, okay, you can do it that way and it works, but actually if you want to change it, you have the problem why you made it this way, why you have the Excel sheet. So this was a funny thing, it worked, and not a big deal in the end. But if you want to change it, there's might be some problem because this person has to agree with the change. But going into my next team, where I'm still now, we had, for another example, we had a weekly architecture round where we discussed 6 team members, only the team members, architecture decisions we had to decide, or what change in architecture, what we will implement, or what risks we see at the moment and what we have to do now. And we sat there weekly, by a weekly basis, and every now and then one colleague came up with a special topic of his, and he said, yeah, why did we decide to use this buy software? Why did we buy this software and use it? There are so many others which might be better than that what we have. And the problem is, yeah, you can ask this question, but it's very problematic if you ask it, for example, 5 weeks in a row, because every time he asked that question, discussion in short. And this discussion costs us 15 to 30 minutes. And if you take that 15 to 30 minutes for each developer, for each team member, then you already have 3 hours. And if you do this for 4 weeks in a row, yeah, you have a few person days which are wasted with discussion. And this also gets on your nerves. And then I walked over to a team member which was there when the decision was made. And he said, yeah, we evaluated a few options, what we would buy. And yeah, that was the best option. So I said to him, hey, please put that decision in a format, write it down. So every time this special colleague here comes up with this topic, we can say, yeah, it's written down there, and the discussion would be over. So that's a little motivation why we needed to document decisions, which leads me to a little bit of derailing. Yeah, but why is it very important in an agile team? And for example, especially for a product developed team, which we are in a DevOps environment, and DevOps environment not as some washed up sense of DevOps, but as you name it. You build it, you run it. We're talking to the customers, we're implementing the requirements, and we bring it to production and we maintain it there. We operate it. So every decision we make, we have to feel the pain of it. And there's no one else to blame but ourselves. So what are we doing in our product development? We are developing the DB Content Hub, Deutsche Bahn Content Hub, which is signaled by this common flower for hubs. And we are trying to solve a problem, which is apparent in a lot of big companies. We have a lot of content in different systems, and sometimes the same content in 3, 4, 5 different systems. And every time you change this content, you have to change it in every system again and again. And it would be much more easier to say, okay, we have one single source of truth for content, and we call it content as a service, and just take the channels via API and drive the content there via these channels. And as a product development team, we have a special thing going. For example, we don't have a subsidiary of Deutsche Bahn as a customer. We are creating this product and have to sell it. So we have to try out a lot of things. We have to iterate fast, and we have a lot of decisions. For example, one of these decisions always is, are we building a product feature which is useful for a lot of customers, or are building a customer feature which is only usable for this customer? And as it is, we have a lot of arguments about decisions, and we don't want to discuss these decisions every time again and again. So now I talked a lot about decisions, but what do I actually mean by design decision? And I will define it now for this talk, so we all have a basis to work on. And the first level, I have three. The first level of design decisions is the code level. It's the basis. So for example, you stumble across a class and you see, oh, there's bubble sort implemented. And you think, why didn't they use quicksort or merge sort? Then as a developer, you can say, okay, I can change that. But maybe that's not necessary because you only are sorting 10 items in a list. So bubble sort is okay for runtime. And actually there is a template for that, which is described by a book from Simon Hara called Java by Comparison. They use a comment template to document this design decision. So if another developer comes along and stumbles upon it, it's an explanation of why something is done that way. But that's not the focus of this talk here. Some of my colleagues also document this outside of code, but I don't see it fits the argument of a design decision. So let's go to the highest plane for me. This is where my talk will focus, and on the level below, it's the solution context. For example, you are a solution architect and say, yeah, we have system A and we have a legacy system B, and we have to implement an interface between them. And you know, oh, system B is really, really legacy. So if you bombard it with requests, you have problems. I actually worked with such a system. And if you had a queue which was full because it couldn't send its request to system B, then the system B, when you bombarded it with more than 500 requests per second, then it just collapsed. And the requests sometimes went missing. They were gone. So perhaps you should implement a pattern to mitigate this problem. For example, a circuit breaker could do it. But that's it. You need circuit breaker. There's no technique involved. When technique is involved, or some framework, then you're working on the application plane. That's where I mostly reside in my team. We have a product and we are working in the application. So when you're in the application and get the idea, okay, I need to use a circuit breaker to talk to system B, then you have a lot of different options. If you're in the Java space, for example, you have Hystrix from Netflix, or you have JResilience, and there are a lot of different frameworks you can use. And I specifically choose Hystrix because I think it's deprecated. So maybe that decision is not as good as you think. Maybe you should use JResilience. And as you can see, every framework has an advantage and a disadvantage. And you choose it because you think the advantages outweigh the disadvantages. But you should document this. So let's derail a little bit further, but I think it's a very valuable topic. I can't ask you now because it's remote and we have a delay here. So usually I ask what the audience knows about ARC42. And when I'm in German, about half the audience knows what ARC42 is. Don't know if that's internationally true, but ARC42 is a template. You also have the link here, https arc42.org. Is nothing more, nothing less than a template for technical architecture documentation. And the very good thing about this template is that it gives you a lightweight structure to document your technical architecture decisions, your technical architecture per se, and everything around the technical architecture. For example, cross-cutting concerns, the runtime view, the building blocks, the context. What systems does my system talk to? And that's very important things. And because it's lightweight, you don't have to fill out every chapter of it. It's a predefined chapter, and the best thing about this, and that's why it's why we use it at Deutsche Bahn, is that the structure is always the same. So if you go to system A and say, okay, we need this documentation, you find everything in the same place, and it's easy to adapt. So for example, I said it's lightweight, and we have this runtime view here. As a DevOps team, we know how we build our software. The runtime view is not of interest for us, so we leave it out. That's very lightweight. That's cool. Sometimes you need a runtime view, for example, if you get 3 new colleagues in your team and there's a lot of swapping around team colleagues, maybe you need a runtime view to get them on board faster. So you just create it. And here comes my one critique of this documentation template. And yes, it's available in a lot of languages. Got translated in English. I think it's Spanish. That's the two that I know of. Yeah, in chapter 9, you see the architecture decisions. And there's different definitions of architecture decisions, or what architecture already means. For me, architecture decisions are the decisions you make for your system that are very hard to change, that are very costly to change. So you have to think about them and outweigh the pros and cons of different options. If you don't have an option, then you have a constraint. That's chapter 2. And actually, the architecture decisions drive your system, and they are based on the quality requirements. And the quality requirements can be specialized quality scenarios, but that's a topic of another talk. So if you're making an architecture decisions, you quite often make a decision that's hard to change. So you should be diligent about it. So what is an architecture decision, and how can we document them? An architecture decision record, an ADR for short, is nothing more than a template, but a very powerful template because it's precise, to the point, and easy to use. So everybody can use a template like this with 2, 4, 6 topics. And if you're not on the application level, as I am, there are also a lot of different templates, and I linked it in the last slide, which are hopefully made available. If not, go to my Twitter, which is linked below. I will post them there later. There are a lot of different templates for architecture decision records. So if you're on a domain level, there's also a template for that. So this is the template I present, which we use in our team, and it works for us. So don't take my word for it that it works for you as well, but try it out. It's a little bit like a Scrum Agile, but without the part where you say, okay, I take the most important parts out. If you don't need, for example, alternative consequences, yeah, then you leave it out. It's okay. You actually work with a template, and this template is based on Michael T. Nygaard's suggestion. Michael T. Nygaard wrote a beautiful blog post, which is also linked in the last slide, where he said, okay, we use this in agile development and it works well for us. And over the last 2 years, I experienced that it works for us as well. So it's a template, it's a title, you say decision, and that's the derivation of this template. Actually, decision, Nygaard says it has to be around here. I think we moved the decision up because we think, okay, the title is important, what we decided about and what we actually decided. It's the most important thing. Then you have a status context. I will talk about that later. So that was a little bit dry. So I brought a real world example from our team, from our system with us. It's a very early HDR. And as you can see, there's some kind of naming convention. We have a prefix called HDR minus, and we decided to use, we decided our system is not as big that we have more than 999 HDRs. And there we have it, HDR 003. This was an early stage HDR for our system, and we're building a content management system, as you might have guessed, because content as a service just implies that. And we bought a a content management service. And this content management system had a very speciality. As many content management systems, it was able to push publish. And push publish says, okay, we have a staging environment and we have a live environment. So if, for example, an editor creates some content and does want to let it proofread from somebody else, he puts in a staging system. And if it's accepted, then it gets push published to the live system. And the speciality of our content management system was that you also could push software updates, which sounds strange, but it was working, and everything that's working gets used. So somebody in the early stages of the product development decided, yeah, it's a good idea to push publish updates to the live environment. You can do it that way, but it had some limitations. For example, the push publishing only worked if you had one dedicated server each for staging and production. And that wasn't the goal. We want to make content as a service, and not with a single server, you're not able to scale horizontally. So this was a bad idea. So we revisit this decision, which wasn't documented, and said, okay, we have to decide about staging versus cluster environment in our content management system. And the decision was made that we use two environments, which are each built as a cluster. And the status here is obviously accepted. We accepted this decision. And here's the context. Why did we make the decision? Okay, we want scalability in the system. Because we need scalability, because we want to serve dozens and dozens. We want to serve everybody. That's the goal of our product development. If it works, I don't know. Serve dozens of customers, thousands of customers, thousands of requests. And it's not possible with the push publishing software updates. And the consequences are in the here and now. We changed the system architecture and no push publishing. It's deconfigured. And as I said, if you don't have an alternative, then you have a constraint. So we have two alternatives: cluster solution, that's cool, operating of the CMS in a cluster, and we have push publishing. As you might have noticed, I said about disadvantages and advantages. Yeah, that's an early HDR. We didn't put it there, and also it wouldn't have fit on the slide. So in the newer HDRs we are using, we have learned as a learning process that we have to really dig deep into the advantages and disadvantages of alternatives. So this was an example. I also have a few brief explanations on the topics because they're, in my view, very important to get. So I will spend a little bit on the title because the title is very important if you have a lot of HDRs, more than 40 or 50 HDRs, then the title becomes very important. And the definition of the title is you use a short noun phrase. Yeah, Captain Obvious, and I know, but you really should stick to that. Get your naming right. I once had a colleague in a former company who wrote Git messages, and they said some errors. Yeah, what? You implemented some errors? Yeah, he should spend some time on your title and not rush it, because you have to, if you have a lot of HDRs, you have to be able to search them in an easy way. So let's get to decision, which we moved up on the second part. The goal on the decision is to be as precise as possible without any double meaning, I would say. So use active language. A brief explanation is okay, but not more than 2 or 3 sentences, as in the example I showed before. And use active language means we implement, we use, we build. Everything with active language is very important, so that it's clear what you are doing. There's no space here for double meaning. Then a very interesting topic which we are running into it are the status. When you start out with HDRs, you only have status decided or accepted. Yeah, and you decide and decide. And how is the decision made? Yeah, you come together as a team, and when you're in an agile environment, it's very possible to say, okay, we have an architecture meeting, or we have something to decide. Let's gather together, discuss the advantages, disadvantages of a few alternatives, pull out this template and say, okay, that's it. We fill out the template and say it's decided. That's how we did it. Yeah. But now we are building our infrastructure again with Terraform. And now we have ADRs which have to be revoked, because Terraform works a little bit different as CloudFormation. So we actually have ADRs which are now revoked, and then I could put as a status revoked or replaced. Revoked means, okay, there is no replacement for this HDR. We sometimes also put replaced there and link to the other HDR. So you get this nice chain of HDRs. You can see how you grew as a team. You can say, okay, we have this HDR and this was preceded by the other HDR. So if someone comes to you, and that's the power of traceability, and says, yeah, why didn't you do CloudFormation? It would be much, much easier. Then you can say, yeah, we did that. Look at HDR that preceded this one and see what we had, what problems we had with it. So this is a powerful tool if you just put the links there. And now on the very important part, if you're working a big company, sometimes there's political things in smaller companies too, but I didn't notice them there as much. In a big company, you always have a hierarchical structure sometimes, and also people who are in power you didn't know about, or you have problems accessing specific data because someone says, no, that's my data and only used for this use case and not for you. I experienced this. So for the context, it's very important to gather everything you need about this decision. So describe facts, only facts, not too emotional. Describe every fact you know about this decision which affects this decision. And these facts are often political, technological, or strategic, or sociological. For example, I had a meetup-driven design architect in my last team. And every time he came from a meetup, which was around once a month, he came back and said, yeah, Apache Kafka. We have to use Apache Kafka. I'm not hating on Apache Kafka, but our use case was around about 15,000 requests per day. I'm not so sure if a distributed streaming platform is the right size for 15,000 requests per minute. I'm pretty sure it's okay to use an Amazon service, an AWS service for that. So you can put this in the context and say, okay, our lead architect wants it that way. So you know why you pulled out a big gun on that. Another interesting story I had when I first started out at Deutsche Bahn was we had the so-called OWT tool. And this OWT tool sounds fancy, but it was for approving migrations to O365 from O360 Office 365. Now I have it to this O365 from an older Office version. And one time I met the lead developer of this OWT tool, and perhaps you can think of the name of him. It was Olaf Walter. So Walter is spelled with W at the front. So he named the tool after himself. Okay, you can do that. Or the context can also be, we have a reactive framework RP decision. That's actually from my team at the moment. We implemented our RP as a microservice on OpenShift. And this RP framework was implemented with Spring Reactive, which was very new at the time. And we set out to serve 1 million customers per second. And it seemed to be a good design decision. Actually, nobody is around anymore to maintain it. Nobody understands it. So we have this big ball of mud and don't know what it does. Yeah, perhaps if we knew that before and weighed the alternatives, then it would be something different. So include everything into the context or the background, I call it. which is important for that decision. Let's get to the consequences. The consequences are the actual things that follows from this decision, the things you have to do. So we are not entirely sure if we will use it in the future, the consequences. I'm not completely sold on it. At the moment, it's structured in positive, negative, neutral, which sometimes overlaps with the alternatives. But at the moment we are using it, we're using complete sentences. And that's the cool thing about HDRs, you can adapt them. If we somehow decide, okay, consequences are not needed anymore, then okay, we ditch them. That's completely okay. Which brings us to the alternatives. I said it before, you have to have at least 2 choices. Otherwise you have a constraint. And you should be very diligent about describing the advantages of each choices and the disadvantages. For example, for our API layer, we wanted to implement tests. And there were 2 approaches which emerged. One was a behavior-driven testing framework called Karate, where we just, it was nearly plain English language to describe requests to the API, which was very cool at the moment. And we used it. And the other framework we evaluated was Rest Assured. Rest Assured was much more code. It was more like unit testing. And we did think it would be better to use the Karate to show our customers how the API is used. And that's actually an example for a good decision at the time. We thought we took it, but it bit us. We implemented all the tests, but they weren't maintainable. So we got back to the HDR and said, okay, what was the other option we used, and tried that one. So you don't have to evaluate when you revoke your decisions, you don't have to re-evaluate all the frameworks because you wrote it down already. So now you're documenting HDRs, and I hope you sold you on that. And you're documenting and documenting because it's easy. You just copy a file or a wiki page and you create HDRs, HDRs, HDRs. And these HDRs have hopefully good titles. I pulled some titles from the internet and also brought one of mine. For example, this is one from the internet. I pulled from GitHub, extend system B to implement interactive approval processing. I really think this is an excellent title because it describes which system is affected by this decision and what it's done there, interactive approval processing. So for example, if you search for system B and something like approval processing, you find this HDR, which is cool. Then the second one is from my team, no customer specific acceptance test. This decision was very interesting because at the start of our journey, we implemented customer specific acceptance tests, which were practically API tests. And there was a problem with that. Every time the data model, which is customizable in our content management system, we had to customize the acceptance tests as well. So one day we sat down and said, okay, that's not maintainable anymore. We have a lot of costs for this and it doesn't bring any good. So we said, okay, we decide no customer specific acceptance test anymore. We will implement consumer-driven contract tests in the future, but this is important. So if you search for acceptance tests in our HDR log, you will find this HDR, which explains why we did it this way. The last one can be a good title, module structure and loading, if you're on the application level. If you have more than one system, if you're on the solution level, I would say that's a terrible title. So it depends on the context, what a good title is. So now you have large decision logs. And I would say a large decision log starts with 40 to 50 HDRs. That's when we encountered a lot of problems with that approach we took, just documenting. We found out that good titles are important, and even more important, and have I already said it, very, very good titles, because you want to search your HDRs. You want to know what you decided if you're stuck somewhere or where, and you want to know where something got wrong. If you don't have a good title, you will not find your HDR, which is responsible for your problems. So good titles are important. And also important is that you're able to browse and search your HDRs. So for example, you can document in Word. That's totally fine. But Word is not bulk searchable. Not as far as I know. I didn't find a way. So if you're, for example, you can use a wiki. This is searchable, or you can use Markdown and pull this beautiful tool I found on GitHub, the HDR viewer. The downside of this HDR viewer and a wiki is that wiki you have to access. You have to have access, and an HDR viewer is something local. So your product owner, for example, or your customer has to install this tool. So it's not very cool to use it, and it's also based on Markdown, which we as a team are not a big fan of, because it has a lot of different flavors and no native way of including Markdown in another Markdown. So modularity is not given at the Markdown. So we came up with a no, not new approach, but it becomes more and more popular, named ASCII-Doc. And ASCII-Doc has a few advantages over Markdown. For example, it's more or less a standard. There are no real flavors of it, not that I know. And it includes a lot of advanced functions as modularity. You can include ASCII-Doc. You just write include the ASCII-Doc, the other file of ASCII-Doc, and it gets included. And you can also customize to include with different level headings. So it's very flexible. And we said, okay, let's use docs as code. Pull up, create a Git repository, put our HDRs, everyone as a file, create a template file. And every time we have to create a new HDR, then yeah, just copy the file, adapt a few tags, add the text, and commit it to your Git repository. For us, this is GitLab. And this will look like that. That's a screenshot from my workspace in IntelliJ. There's a really, really good plugin for ASCII-Doc created by Alexander Schwarz, arhus1.de, as far as I know, IntelliJ ASCII-Doc plugin. And it's a pleasure to work with this plugin in IntelliJ and ASCII-Doc. And as you can see, it's a repository, and we just have our chronological log of our HDRs, which is cool because it's versioned, and we can use the same tools as we use for code, for infrastructure, we can use for documentation. It's easier to use for the common developer, and for us are easy. We also convinced our product owner to use it, which GitLab gives you a nice web IDE, and even he is able to use it. So this approach is also applicable for product owners. Don't bother, this is in German, because this talk is normal in German, but you will get the gist of it. And then we have this Git repository with HDRs, and we use JBake, a static site generator, to create a microsite out of these HDRs and our technical documentation. So as you can see under architecture, there's the Arc42 templates with the 13 chapters. And now we have our technical architecture here, and under news, we render the HDRs as a block chronologically. So, and we can link in this microsite to the technical architecture documentation. So for example, if you decide something, you can say, okay, we decided to build it that way, and here's the technical architecture documentation, where you can see how the architecture looks like. So you get this browsable easy to use because it's only HTML. Every browser can show it. Even if you don't have any IDE or code knowledge, no problem. You have an HTML file. Chronological sorted ADRs. And we also, that's a cool thing, our system is built from a backend system and an API. And we began to tag our ADRs. So as you can see, January 6, 2020, it's an old screenshot here. But okay, it's something about API. So we tagged it this HDR API and this API. And we have also a core system. So we have a tag core system. So if we are working on the core system and some decision comes up, okay, what do we do there? Have we any HDRs for the core system? Yeah, okay, we can click on the core system or at the next screenshot at the API. And the microsite shows us all HDRs chronological sorted, which are related to the API. So that's a powerful tool because you don't need any development tools and you get with a static site generation a graphical view of your HDRs. So, and I'm very proud of the technology behind the microsite because it's very powerful. So I will talk a little bit about that and how powerful it really is. So for example, with AsciiDoc, you can say, okay, my technical documentation lives in the same repository as my code, for example, or it lives in a different repository. So you have your repository for your microsite, and then you can pull in all different repositories. For example, you have a user documentation. Yeah, I want to have it in the microsite. Or you can say I have a technical documentation. Yeah, I pulled it from there. And actually, a colleague of mine wrote a framework called Monaco, which you use in one framework, and you can pull all different kinds of documentation into one microsite. But that's not what we use. We use Doc Toolchain, which is developed by another colleague from me, Ralph D. Müller. And this Doc Toolchain is more or less a groovy collection of groovy scripts, which is able to create from AsciiDoc all different sorts of formats. For example, we can create a microsite here, or we can create a PDF, or we can create Word or PowerPoint. Every time your customer needs a specific documentation, you can just set up an AsciiDoc file, which includes the necessary parts. For example, a user documentation doesn't need the technical documentation. So you only pull out the user documentation. And then you say, Doc Toolchain, render it in the specific format you need. So it's extremely flexible. And one thing we also noticed when we look back at our wiki time, I would say, our wiki time, we had the documentation in a wiki, and the wiki tended to be developer prose, as someone called it in our team. So there's a saying in Germany which says, Wiki, ist das nicht der Ort, an dem Dokumentation zum Sterben hingeht? Wiki, isn't that the place where information goes to die? Yeah, that was also the problem with our documentation. So there was if you look at one page, there were HDRs in there were technical documentation in there, there were rants in there, ideas, everything you can think of was in one page. It wasn't structured. And we found out that this problem stems from not peer reviewing your documentation. In a wiki, for example, everybody can put a site there and dump everything he thinks is necessary in the site. And nobody looks over it. And we set up our microsite a different way. We said, okay, we have the main branch, and this branch is protected. And if you want to change the microsite, you have to branch out for an HDR 42, for example. And then you have to peer review via pull request, or in GitLab merge request. And if you want an HDR to be distributed among the whole team, we created this team rule and said, okay, HDRs have to be at least read by the whole team. And this created the pressure that everybody knew what was going on in our system. And by peer reviewing, that's a natural occurrence. It happens that the documentation gets structured a lot better. A lot of times you have a merge request and you see, oh, this is bullshit. Just we have to name it a different way. Or someone says, no, this is bullshit. We have to veto this. We can't decide that way. And that's possible if you set up this process. So if everybody approves, you say, okay, it goes in the documentation. You also get the buy-in. So if nobody vetoes, everybody says, okay, we're going with that decision, and it's better for your team. So that was the team level. Let's take a bigger view for a corporate environment I'm in. So for example, we have my team, and we create a microsite and make our architecture decisions transparent for everybody in Deutsche Bahn, which is okay because it's knowledge which was created in Deutsche Bahn and should be made available to everybody. So team B and C, or the whole corporation, which consists of over 300 development teams only for DB System at the moment, can view the architecture decisions. This might not sound like a big deal, but I have a little calculation brought with me, which is very simplistic and not at all correct, but shows the extent to which transparency helps you be efficient in your whole organization. So, for example, everybody is using continuous integration, continuous deployment. So everybody has to decide, how do we store secrets so that they're traceable, versionable, and versioned is the most important thing. So you can store secrets in GitLab as GitLab variables, for example. But everybody with access to that GitLab variable can change it and wreck your build. And nobody knows who changed it because there are no logs. So you have to come up with a better way to store your secrets because they've rotated also. So for example, let's say one team spends 5 person days to decide how to store secrets the way they should be stored. So this costs 1,000 euros each, for example. That's not an exact number. I don't know the number of what a person day costs at my company. So you have 5,000 euros for this decision, for this team. Now I said, okay, we have 300 development teams, and say 200 or even 300 teams have to decide the same thing. Remember, it's only one decision. You have a dozen decisions and more. And 300 teams don't know of any decision another team made. And you have to say, okay, they all have to spend 5,000 euros to come to the same solution. Yeah, congratulations. You just spent 1.5 million euros only on this decision alone. That's money you can save. And if we are talking about 50 or more decisions, which are not all relevant for every team, but for a lot of teams, and if only you save 5,000 euros for one decision, that's already worth it to document it, to make it transparent. So how do we do this at Deutsche Bahn, and especially for DB System? If you paid attention, there's this little search button on the microsite, and this search button is linked to our internal search engine. And this internal search engine works very simplistic. It just our microsite just runs a sitemap, and now a bot comes around and collects everything that's on our microsite and also the ADRs. So if I search in this button, it will put the site double point and your site, and you can search the ADRs for our site. What we are building at the moment in our architecture guild, we are building a log of every architecture decision there is in Deutsche Bahn. So it's more easily searchable. But that's the power of an internal search engine when you use it when you use a microsite for that. So I got already a signal to come to an end, and fortunately I'm at the end. So to sum it up, HDRs are very usable, have a use case if you need traceability and transparency of decisions, and they accrue as a chronological log, which is easily searchable. But if you have a lot of architecture decisions, then they become hard to manage. So you have to come up with a different solution than, for example, a wiki. We as a team said, okay, the Docs as Code approach is very cool for us because we can use the tools we need, and we can also use Docs as Code to render a microsite and create an HDR log, which is easily searchable. And we made it even more searchable through tagging, so that you can tag different architecture decisions where they belong to and make it even more easily accessible. And what you already learned is if you make your architecture decisions transparent for everyone and connect these transparent architecture decisions to the internal search engine, then you get the benefits of saving a lot of money and coming up with a standardized way of solutions. So I'm at the end. I hope you enjoyed it. You took away something, or you totally don't agree with me, which is fine. I don't sell silver bullets. I just present what we are come to appreciate with the techniques we use. And that's it. So I have to put my moderator here, so I look.
Yeah, it's I always have to look above the camera to see people. So hi Johannes.
Hi.
Very cool talk. So yeah, you can count me in. You converted me. Yeah, it's
yeah. I hope you share your experience with me, because I'm still learning.
Yeah, it's I think it's a journey, and it's a very cool tool to put into your belt as a team, and to make it also easier for people who join later to grasp everything and to make everything like really easy to handle. I think this is I think you enjoy this as part of your whole process. So there are these things here. Oh, wow. So you will love this. The number one Q&A thing is love your talk, very informative. Yeah. And then
Thank you.
second comes kudos to your presentation. So,
I hope the translations were okay.
yeah,
I spent a lot of time on it.
it was very good to understand. Yeah, it's and I would even take the one of the things which is like at the bottom. It says, and kudos to your team, because it's also an effort to really live it and to build the whole infrastructure you need. So
Yeah, and we make a lot of false assumptions and decisions along the way, and we are allowed to do it, which is cool. But
Yep.
you have to document your wrong decisions.
yeah, but if you do not make any decisions, you cannot be successful. So that's the thing. So you see, I have this colleague who is pulling up and down my neon sign because he's trying to fix something. So this is also, we have to fail somewhere. So the first real question, how much time does it take your team to create one of these ADR entries?
Okay, create it. It's done in 1 minute, because
Yeah.
you just copy the file in IntelliJ and push it and create a merge request, which is completely automated. Sometimes it's hard to get the review. Yeah, you get everybody to review it, to make suggestions.
Yeah.
So we have this weekly team time. We call it team time, which is more or less an architecture meeting of the team, which works pretty well, where we come up and look if there are some decisions which need to be approved. So this is a nice tool we developed over the last half in a year. We say, okay, we sit down for 2 hours a week to review the documentation.
Okay. And do you are you in Agile or in Scrum or in Kanban?
Yeah, that's so we're working in a corporate environment, which is transitioning to Agile, but we also have these edges where we have also the hierarchical structures, for example, for the subsidiaries. So we first worked in Scrum, but as we are all intrinsically motivated, we had a problem with Scrum because there were always stories which didn't get finished. So we transitioned in January, I think, to Kanban, which is much more enjoyable as a product development team. So no, we have a weekly, but no sprints whatsoever. We just pull the latest card from our backlog and then push it through the lanes.
Cool. Sounds like fun. So
yeah, sometimes. I'm not really enjoying infrastructure work because it's really hard. For example, if you're managing servers in AWS and something does not work, it's usually the network, and networking is a hard problem.
Yeah, I can believe that, especially in a corporate environment where it's not that you just flip some switches, but it takes you, in German you say from Pontius to Pilatus, or
yeah, sometimes it's like that. We have an AWS account, so we are relatively free, but as soon as we are going to other systems which are not in AWS, it sometimes gets tricky to get a connection.
I can imagine that. Then somebody said, ha ha ha, love the OWT story. This was really a great story.
Yeah, I'm really amazed at how that got through. Normally you have naming conventions here, everything is somehow regulated, and then you come up with a OWT. So sometimes nobody looks.
Yeah, it's like, sneak in from the side and then
yeah, and then it's there and you can't change it.
And you can't change it, that's true. So then apparently another of the anonymous people said, I'm sold, and then there are at least 2 people who upvoted it. So counting me in, you converted a minimum of 4 people to...
yeah, I heard if you reach 10% of your talk audience, you're good. I don't know how many people there are, but 4 is a good number.
Yeah, but this is only the beginning, because once it's in the internet, it's there forever. So we can make a revision version next year, if you like.
Yeah, no problem. I'm sold too.
So, and then another anonymous person says, your English is actually very good. Thank you for your talk.
Thank you. I know my pronunciation is very good, but I struggle with vocabulary and grammatic. To be honest,
we all do, or it's it's very human.
It's better to give this talk in English as a German as an English speaking person in German. So
yeah, I
German
guess
is a hard language.
Yeah. So, and then somebody said, cool talk. Hey, come on, guys. These are all your questions on ADRs. Maybe this is because you explained it so well. What I really liked is also how you let us participate in how you actually build this this platform which you use for documentation with the search box and all the tools you do. And I was really, I never thought of this, and this is where you opened my eyes, because for me, if I want to, I want people to read some how do you call that? Clear text, clean text files, yeah.
Plain text.
Plain text. That's it.
Word files.
Yeah. Then
Word files.
Then I always think of Markdown, yeah. But I never thought of ASCII, yeah.
Yeah, this is. There are two camps. Somebody also said ASCII-Doc is too complex. But every time I use Markdown, I do not get it right because every flavor is different. And that's,
it's like when you use
major
it
pain.
in Wikipedia, it's different when you use it in some implementation which is in your code editor, and then you change the code editor because you do something else, and then you start crying because I don't have to tell you, I think you have been there.
Yeah.
Okay, so the two of us, we are actually the ones who will close down this day, and we will pull all the plugs and turn off all the lights and take away the electricity from the internet. So
Don't call it. We already had internet problems.
yeah. So that being said, thank you very much for being the one who gives the last talk on this day in a topic which is very, let's say, enlightening, and which gave me a lot of stuff to think. Yeah, now you can imagine what I will dream of, because this starts the motor here. And I think my my colleagues are already turning off all the lights. Okay, so bye bye, Johannes. Hope to see you soon, and for all you people in front of your screens, I hope to see you tomorrow on Blockchain Day. And tomorrow morning we will meet with Steve Shadders, who will be the moderator of tomorrow. So this will be my last full day moderation. Apparently I deserve it. Yeah, okay. Before people start throwing things at me, I will turn on the loop and we can sneak out the back door and go for a beer. Bye, people in front of the screens. See you tomorrow. WeAreDevelopers out.